And the interlayer we're building, we give it a name beacon layer, is actually acting like a marketplace for sequencers. So when you initiate a transaction to the rollup, the beacon layer will automatically help you assign this transaction to the users who are operating the sequencers. Of course, how do you qualify as a user to run sequencers for the rollups you like? You need to stake Ethereum and other restaking assets to qualify, and you might get slashed if you have any wrongdoing. That's why I said it's kind of like a post-chain network where there's value creation and capture in this network, and also the users are essentially acting like gatekeepers in this network. They stake assets, they get assigned to basically run transactions, order them and execute them, and then they get staking rewards. And after the rollup transaction is processed, they also get verified through our building function using WASM VM. So besides just processing the data, we also provide an extra layer of security by a verification using WASM. So throughout the process, there are actually different tier of security or finality you can get. When we process or order the data, the transactions through the sequencers, we would call them soft final. I don't know if you guys have ever made a transaction on Uniswap, on Arbitrum. For instance, when you swap ETH into Tether on Arbitrum, your order has not been sent to the mainnet or the underlying chain, which is Ethereum in your case. So you are only arriving at soft finality, which means your data has not been final approved by the whole network, and Ethereum does not recognize the legitimacy of your transaction. But normally, as a user or as a trader, we don't really care. As long as Arbitrum tells us our transaction is final, we see it as final. That's why we call it soft final. So what Interlayer or beacon chain provides in addition to that soft finality is a verification level finality that's through the building function we just mentioned in WASM that would allow you to get a higher level of security after you make that transaction on Uniswap. So instead of saying, oh, my MetaMask has confirmed my transaction. Now you can say, oh, the beacon layer has confirmed my transaction. And since the beacon layer is run by a decentralized group of users, and they run the sequencers and process my data, so I can roughly believe that my transactions are really final and secure. And then we have the hard finality, which is when the transactions are actually sent to the base layer in Ethereum in this case. And normally with optimistic rollup, you have 7-day waiting period. It's until the 7-day wait period is over, then you can call the transactions hard final. That's when the transaction is confirmed by everyone in the universe. So I do have a question for you guys, just in case you fall into a sleep. When you bridge an asset using Arbiter Finance or, I don't know, Kinesis or any other bridge, after you see MetaMask shows confirm that your bridging transaction is through, like what level of finality have you arrived? Wow, you guys are so smart. You're the first audience that got this question right. You should be really proud of yourself. Thank you. So what AltLayer is providing, the Interlayer is adding an extra layer of security to that soft finality. So you can say you have arrive at verification level security. That could mean DeFi protocols and other protocols can utilize this functionality to enable cross rollup messaging and the transfers. And also the Beacon chain or the Interlayer would enable upgrades without hard forks, which is also an important functionality for builders. You don't want to always hard fork your chain whenever you have an upgrade. That's something a lot of existing rollup technology does not provide, and we proudly support forkless upgrade. So before I end this sharing, I would like to also show you guys what we also provide is rollup as a service. So as I mentioned, we provide interlayer for rollups, but if you do not have an existing rollup and you want to build one for your app, then we also help you spin up rollups within 2 minutes using our standardized platform and SDKs. So these are all the components you can basically customize for your own chain. For instance, you can choose what sequencer network you want to use, what rollup stack you want to use. As everyone knows, OP Stack, Arbitrum Orbit, Polygon CDK, and Starknet. All these rollup stacks are pretty normal nowadays. So you can freely choose whichever rollup stack you want to use for your own rollup. And also you can choose to customize your DA layer, whether you want to use Celestia, EigenDA, or Avio. It's all free for you to choose. And we also have partnership with a lot of the bridging projects, so you can freely choose whichever bridge you want to use. And the underlying chain, besides Ethereum, you can also settle your transactions on, say, OPBNB or Polygon zkEVM chain. It's all up to you. And of course, you can customize your gas on your rollup, whether you want to make your own token as a gas token, whether you want to make it gas-free, like a gasless experience in a game. Everything is customizable. So if you're building a game, a social network, or a DeFi protocol that actually require very high performance, high security, and full decentralization, you can come and talk to us. We can help you. That's all. Thank you.
Thank you very much, Dorothy, for the lovely presentation. All right. Oh, wait, hold on, Dorothy. We'll see whether they have any questions or not. Lovely presentation. I learned a little bit more about soft finality and hard finality, but I think you're right. To the user experience, hard finality doesn't really matter. We just, if Arbitrum says it's done lah. Okay, can we open it to the audience? Does anybody have a question? Please raise your hand and then we'll pass you a microphone. Anybody has anything to ask? The way she's describing all, like you have solved all problems in the whole world of blockchain. Gasless also can, forkless also can, this one also can. Wow, amazing. Any questions? If not, okay, you got one over here. Can we pass a mic to him? Our volunteers will come and hand you a mic. Please introduce your name as well as your question to Dorothy.
Thank you. Hi, I'm Keith. Just a question. How can we test AltLayer?
There are a few ways. The first way is to go to our website. Actually, I think it's here, dashboard.alt.technology, or you can just go to our website, AltLayer.io, and then you can find the rollup launchpad where you can just play around with our platform. You can basically choose whatever tier you want to use. You can start with a free trial, and the chain will automatically terminate itself in 2 hours. So there's no waste of resources. You can spin up as many rollups as you want at the same time, and you can choose the gas model, etc. So if you are looking to test the rollup with more functionality or more customization, then you can reach out to our team for email, Twitter, TG, whatever, or you can speak to Wen Hao, who's next to you, our BD. Yeah, so yeah, I think that these are the 2 main ways you can test our product. Of course, we also have some other projects that are working with us. There are a few gaming projects that are launching using our rollup stack, especially for fully on-chain game. We have built a specific rollup framework called Turbo, which would allow gasless transactions, burner wallet, and like horizontal scaling, which means we can spin up 100 rollups at the same time, which serve as gaming server. So instead of squeezing everyone into one rollup, now gamers can choose whichever rollup they want to use to play the game, more similar to a weather with Blade Out and another project called Cellular. You can play these games through our platform. You can check out all the information on Galaxy. Thank you.
Excellent, very comprehensive answer. And I like that your website has a very nice dashboard that you can easily test out your rollups. Okay, anyone else want to ask a question? You got one here in the front. We'll get our volunteer. Got two. One here in the front, then the lady at the back. Okay. Our volunteers will come and pass you a mic. Please introduce your name and your question. Thank you.
Hello, Dorothy. Thank you for your time and your talk. My name is Izo. I would like to ask you, what is the benefit for AltLayer to provide such good service? Basically, what is your business model?
Yeah, so the business model is actually in the Interlayer we just mentioned. So our vision is that in the foreseeable future, we'll have a lot of infrastructure in the industry will not be able to accommodate 1 million users, not even 100K users. So by owning the block space to itself and also customize the chain in the way they want, and also through the powerful WASM and other VM technology, we can support projects to basically service millions of users at the same time. Especially for gaming projects, I think it's inevitable that they would have to use this horizontal scaling solution to service millions of users at the same time. So to support this vision, all these rollups will need a decentralized network to run sequencers and validators, because the cost to run its own validator network is quite high, and also the gaming project or the social network project team are not expert to run decentralized network. They're running into security issues like running chain and other projects. So this network would help projects to basically forget about all the overhead and all the DevOps they need to spend energy and money in to solve all these problems. They can simply just use our solution. And it's a decentralized network, so we'll have a token. And users will be able to stake Ethereum and our own token to support this network. So to promote this decentralized network, of course, we need to work with as many projects as possible, and providing RAS service is another way to lure them into our ecosystem.
Thank you.
All right. Last question was at the back, lady in green. Thank you very much.
Hi, Dorothy. Thank you for the presentation. My name is Shannon, and I'm from CoinGecko. I just have a quick question on the aggregator step that you mentioned just now. So just wondering if the aggregator function, does it work like a zk rollup? And if yes, would you say it's easier for project who is using zk rollup to onboard to this beacon layer that you're offering?
Yeah, so this framework is actually execution model agnostic. So you have aggregator that's basically aggregating orders. It doesn't really matter what execution model you choose. So we do support optimistic rollup in our own test stack right now, but we kind of took a hybrid approach where you basically process all the data in an optimistic way. And then whenever there's a challenge, we use zk prover to prove the transaction. So it reduces the cost and overhead tremendously. But overall, this interlayer network wouldn't be like a execution model specific. We can support both zk and OP stacks.
All right. Thank you.
Thank you.
Thank you for the question. Great questions and great answers. Let's give Dorothy a big, big round of applause. Thank you very much, Dorothy.
Thank you.
And of course, if you have any further questions, feel free to go and reach out as well. Very interesting project, I must say. Very, very useful as well for developers who are interested in deploying rollups. All right, so our next topic, right on the dot 2:30, our next topic is going to be about Starknet. So we're going to be learning something from Starknet. We've got our speaker. Okay, a few people are going to another talk. No problem. Bye-bye. You have abandoned us. It's okay. You can come back later. No problem. All right, we'll just let them exit the hall. No worries. Now, there are simultaneous talks going on. There are also going to be some workshops as well happening. So, of course, check out the agenda online and decide where you want to place yourselves. Okay, our next talk is about Stockpiled with Starknet. Yeah, our speaker is Cheechyuan from the Starknet Foundation. He's going to be, as ambassador from the Starknet Foundation, he's going to be explaining a bit more. So for those of you interested in Starknet, this is the place to be. All right, let's give him a big warm round of applause as we welcome Cheechyuan to the stage to share a little bit more with us, a little bit more about Starknet. All right. You can take out the mic also if you want to walk around. Yeah, just take out the mic as well.
Like that?
Yeah, that's fine.
Oh, okay, it works. Cool.
Okay, go ahead. The stage is yours, bro.
Wait, let me give it a try. Okay, cool. Yeah, it works. Hi, everyone. Thank you so much, Ross, for the introduction. My name is Cheechyuan, Cheechyuan, or whatever. Convenient for you to mention. I represent the Starknet Foundation. I'm an ambassador at the Starknet Foundation. If you see me running around, because today I'm also an organizer for the event, and I'm so happy for that. I see all of you guys here listening attentively, coming all the way from all parts around the world, coming to Malaysia to enjoy ETHKL. Thank you so much for coming. And I also work for Nethermind as a developer. So I got a couple of hats, but today my role is I'm an ambassador for Starknet Foundation. So my topic, Starkpilled with Starknet. So basically, Starkpilled means that I'm trying to give you like the tablet, the pill, the medicine, try to get you, how can I, Starkify you, like to make you involved in the world of Starknet. So hopefully at the end of the talk, you always hit me up. So first of all, let me give you a motivation as to what my talk is about and why do we need Starknet. So what is the state of Ethereum now? So over here, I took a screenshot of the blocks that has been produced on mainnet. This is an ETHKL Explorer website. Obviously, if you want to check your blocks, that's where you go. And what I'm trying to say is that we notice that the block production is consistently at 12 seconds per block. And we roughly see around like 140-ish transactions in 12 seconds. If you try to do some math, it turns out to be around like 11 to 12 TPS. And the gas price is around 70 Gwei. I've checked that and I just put it here to make it convenient. So if we were to ask the question is, how do we make blockchain in such a way that it scales? How do we make blockchain in such a way that it reaches infinite amount of people in line with the infinite garden concept? 12 TPS, which is 12 transactions per second, this doesn't make it. This doesn't make sense, right? We need to achieve like 1,000 TPS, like even if everyone's using it on a constant basis, like 1 million TPS, so on and so forth. So this is a problem that we are facing today. Yes, and one thing I want to stress that if you were to perform like a simple swap on Uniswap, like if you easily could spend like $25-ish, $23. If you want to pay your friends, return your friends the money that he or she spent on coffee, which is like $3, but you're paying $7, $6 for a simple USDT transfer. So your transfer is basically more expensive than 2 cups of your coffee. So what does it mean? It means that it doesn't make sense for you to perform simple, easy transactions on the mainnet anymore. So what I'm trying to draw attention to is that Ethereum nowadays, it works. It is doing what it's supposed to do, but it's not enough. Right? It's not enough to reach what we want. We want 1 million people to use. We want a billion users to use. We want 1 million transactions per second, so on and so forth. So the state of Ethereum right now, TLDR, it's not good enough. And Starknet aims to improve that, and we'll see how it goes. Let me quickly explain like why it is happening. So in a typical layer one, like in Ethereum, for example, what happens is that everyone creates a transaction, sends it to a mempool, and the block producer will then validate the block. And what happens is that every single node in the space will then re-execute the block to validate to see if the outcome of the transactions in the block are correct. So that means everyone's doing the check. So what it means is that even though like I produce the block, like all of you are like participants in the blockchain, 1, 2, 3, 4, 5, like 20, 30 of you, will need to re-execute the same thing over and over again. We can think of this as like we're just repeating the work that your friend is doing, and he's repeating the work of his friend is doing, her friend is doing, blah, blah, whatever, so on and so forth. And this is a problem that this is something that has to be done to make sure that it's valid, but it's also a problem because you're wasting a lot of resources. And that limits how much TPS can go in a network, right? Because not everyone can have a good enough machine to execute like billions and thousands of millions of transactions with a simple Mac, for example. You can't do that because it's too expensive or exhaustive, so to say. So there are a couple of solutions. Let me introduce you one of the solutions that people has used. So solution number one, another faster L1 chain. Not going to name names here, but we have seen a couple of so-called faster L1 chains that appear like, oh, we scale Ethereum, we are faster, we are cheaper. This is the claim, right? So what they're actually doing is that they sacrifice on this thing, this very important factor called decentralization, which is what blockchain has been preaching about since day one. They how can I say, they gatekeep, not the gatekeep, they price out users who are not able to afford expensive machines, because and in exchange they are the ones that are running expensive machines gets to run like the million transactions. So let's say I have the funds to run like a 1 terabyte RAM machine, but probably he or she doesn't have the resource, then he or she cannot participate in the network because you simply do not have enough computation power to be a part of the network. And that is something that is a huge sacrifice. So at the end of the day, we can think of like, we are pretty much going back to a centralized system. There's no point of having blockchain if we were to do that, right? The Web2 world works, bank transaction rarely fails. So if we were to do it, to some point, like, why are we even talking about decentralization, and why are we even talking about blockchain in the first place, right? So the second approach that people has come up with, which already been done, it's what we call the optimistic approach. So what happens is that one single party will run this very heavy execution, but only one. What this person do is that the person will send the data to layer one. And optimistically, that means you do not verify yet, but you trust that the execution is done correctly. And what everyone can do in the ecosystem is that you can run this thing called fraud prover. So you are going to always monitor the chain, and you're always going to like be like a fisherman trying to fish out like, oh, if any transactions that are made by this so-called sequencer, it's malicious or not. If it's so, you're able to then engage this thing called a fraud proof, or this fraud challenge. You're able to challenge the sequencer in a back and forth manner, saying, hey, you have done something wrong. If you are, then you are slash, and so on and so forth. So the good thing about this is that, okay, sure, you only need one person to run this heavy execution, and you only need one person to perform this so-called fisherman activity in a very correctly. So you only need to trust one out of many people. But at the end of the day, we're going to ask, like, okay, everyone is assuming that if only one person is running it, like, who's going to run it at the end, right? Like, if I'm not going to run it, are you going to run it? Probably not. Like, because running the fisherman thing could take a bit of resource. Like, what is my motivation? What is my incentive in running it? So this works, and it's mainly backed by this thing called game theory. So it works. It's working right now. It's the good examples are Optimism and Arbitrum. They are working very well. This is another solution that people have proposed. The third solution is what we call the validity rollup approach, where, again, similar to the optimistic approach over here, one single party will do all the execution, and the data that is being executed will then be published on the layer one chain, similar to how the first approach, the second approach was. And in addition to publishing the data, you also publish this thing called the proof. So you're proving that the data, the state changes are being done correctly, So thereby eliminating the need of a fisherman having to always monitor the activity of the chain. So when the proof is generated and when the proof is verified, you are assured that there's no one that can, there was no cheating, no malicious activity, no foul play was involved in generating the data on the state changes on L2. And this is based on mathematical proof. And in Starknet, in the example, we use Stark proofs. There are various couple of options, and there's a zk track tomorrow for those who are interested. Highly encourage you to go and ask questions over there. There's a panel as well. But today we are going to talk about Starknet and Stark proofs. So as a result, what happens, right? Like this is already live. It happens like a couple of, I don't know, I forgot when, like last month or something like that. We have seen like a massive spike in TPS. So that means we have achieved like 122 max TPS already. Doesn't mean that this is our limit. It only means that this is the limit of the users. Users are not using enough. Like if there are more users, it could go even higher. But this is the limit of users. Doesn't mean that Starknet can only go to 126 TPS. No, it doesn't mean that way. It means that we need more users on Starknet so that we can push the boundary. You know? Probably 1,000, 2,000. We'll see. Yes, so this is the result of doing the second approach. Third approach. One thing I would like to talk about Starknet, which I feel that is very innovative among even the L2 space, is we have this thing called a native account abstraction. So we have heard of this thing called 4337 account abstraction using our mempool. Has been going around. People are talking about like gas abstraction. You don't have to pay get native fee, blah blah blah, whatever. That means that if the validators are not doing that, that means you will need to wait for another block to possibly get your transactions included. What native abstraction does is that without every single transaction, it's an account by default, and every single block will definitely read from this so-called mempool that accepts account abstraction. What happens? A quick introduction is that what happens is that in the traditional world, we are used to having a private key being associated to a public key or address. In the account abstraction world, you have one address. You have every single account is a contract, and your so-called public verifying key or public key is being stored on the contract in this. And then what the sequences will do? The sequence is going to run this entry point contract that will then call the verify plus execution transaction in one step. So if your verification fails, your execution fails by default. So that means the verification stage is where you check make sure that your signatures are being done correctly for the transaction. So I mentioned verification as execution stage because they're very important. In these two different stages, you can play around, you can implement new cool stuff to it. And over here, I list out 3 very, very cool use cases that have been implemented by a couple of people. On the verification stage is where you're able to play around with your so-called private key. You're able to change your private key, but you are able to reuse the same account, right? So imagine like if I were to lose my private key, in the Ethereum world, I would essentially lose all my funds that's associated to a private key in a EOA wallet. But when it comes to an account contract, what you can do is that if you have set up your smart contract to accept this called account recovery mechanism, you can probably change your password or even forget password. It depends on how you want to implement it, and you're able to then retrieve or recover your funds that is locked onto that account. So these are one of the things that you can play around with the verification stage, because that's the stage where you check for the address, and you can be a bit creative there. You can even implement like a multi-sig algorithm to check for multiple signatures. Make sure that you can then execute a transaction even multiple signatures, so on and so forth. So it's up to imagination as to what you can do in this stage, right? And then you have this, then after the verification stage, you will then call the entry point contract, will then all call to the execution stage. And let me remind you of the current status quo as to how it looks like when you're trying to make a swap on Uniswap v3 on mainnet. So typically for a new token, if you are trading between 2 new tokens, what you're going to do is you're going to approve like multiple times, like approve here, and then finally you approve swap, like so 3 steps. If you have multi-call, probably if it supports multi-call, maybe 2 steps, 1 step. But with account abstraction, the execution stage, it supports multi-call by default. So everything is going to use 1 step. You can approve, swap, and unapprove, right? Everything in 1 step without having to like, click, wait to get mine, then you click again. Like, maybe you guys are used to it, but that is not acceptable should we want to onboard like millions of users, right? Like we are used to this very quick grab thing, like swipe and you pay thing. We want that to, we want to see that on the blockchain space, right? So yes, this is one thing that I really want to stress out. Multi-calls are something that is so underrated, so overlooked, and people just take it for granted. At least I did. And this is how basically multi-call looks like. Like you can see that this is a block explorer on Starknet. It's Voyager, the team that I'm working for in Dynamite. A bit of shield there. So in the same transaction, you can see that there are multiple calls, and these are happening on the same transaction. So in the Ethereum space, you can only make one function call, but because of multi-call on Starknet, you can make multiple function calls. You can make 2, 3 calls, 5, 6, 7 calls. As long as you have the gas to pay for it, you're good to go. And that's basically about Starknet. Like Starknet has net account extraction, we go through the motivation of why we need Starknet to scale blockchain, and account extraction is cool. And I would like to introduce you to something that is very unique to Starknet. Cairo. Cairo is a smart contract language on Starknet. First up, a quick meme here. Like you'll be wondering, for those who have like, why do I need a new language? And for those who have seen Starknet, you probably have seen it change over the months. It's not even a year, over the months. And Elias over there is like smiling like, over the months. So yes, why do you need to learn a new language? It's because Cairo is created from scratch, right? So that you're able to then create proof from the execution trace in a very efficient way. So what I'm trying to say is that unlike the traditional Solidity and the zkEVM approach, to make the proof generation very efficient, the Starknet team rewrote the entire language just so that the proof generation is very efficient. So Cairo is built to generate proofs. And you can then go on to write advanced machine learning models in a very intuitive way using Cairo. And I mentioned Kakarot zkEVM over here because they are great. They are one of the great examples of the usage of Cairo. They wrote the entire zkEVM stack using Cairo. And the new Cairo syntax, Rust-like, very expressive, very explicit, very readable. As if you like Rust, you will like Cairo. Yes. And I want to remind everyone that Cairo is a general programming language. And on a subset of Cairo will be the smart contract on Starknet. So using the same concept, the same language, but a different library, you can import different libraries for a smart contract. You're then able to deploy your contract on Starknet. But not to be mistaken, you can also write general programming language such as zkEVM, such as an AI model using Cairo. As long as you want to make sure that your execution is provable, Cairo is probably something for you. So how it works is that Cairo, in this step, will then do the execution and then generate the proof. This is a very hard step, right? And then you send proof over to in a very small light computer, and then you just have to verify the correctness of the execution. So Cairo over here is able to then compile your code down to proofs, and then the proofs just verify the output in a very lightweight computer, and there you go. You don't have to re-execute it. So this is simply basically the concept of me sending proofs, and you just verify it to ensure that the state change is correct. So what are the alternatives to that, right? One of the examples we have is zkEVM. For those who are writing ZK circuit, zkEVM is also trying to do the same thing. You're trying to prove the execution is correct. But zkEVM is, you have to kind of change your mental model in writing zkEVM. It's not like the language that we're used to. You have to represent all your logic in circuit. You have to make sure that you constrain your circuits for soundness. If not, there's a potential exploit on your circuit. And it looks like this. It looks very different from your TypeScript, your JavaScript, your whatever Python that you're used to and love. It looks very different. Like basically, you have to learn a new language entirely. You have to change the way you think, and I think it's very hard compared to learning Cairo, to be honest, because Cairo is like you don't have to change that much. Learn new syntax. But zkEVM, you have to like kind of change the entire mental model. So there you go. Other alternatives like Hello 2. Hello 2, it's basically do not have a DSL. You still need to learn Rust to use the library of Hello 2. It's another beast. Sure, it achieves great things. You have recursions, but use it. You need to you need to learn how to write circuits as well. And then even worse, you need to like know what API from the library to call. So what I'm trying to say is that Cairo is a very simple way to prove your execution. by writing the code that we are already used to. So high-level overview of what Cairo to proof looks like. First we have Cairo, and then we compile down this thing called Cairo assembly, and or we call CASM, C-A-S-M. And from CASM, we will compile down to add traces. Add traces basically describes the execution in numbers. So we have this long trace that are felts, a few elements, and that is basically describes the behavior of our program. And from add traces, we will then convert to polynomials. And from polynomials, we'll then create a start proof out of the polynomial. So basically, this is like a very high level overview of how you convert your code to proof. And I want to stress that for those who are afraid of touching Starknet because you're afraid, oh, it's very hard to use, dev tooling is not that great, we have Remix. So Remix is where I learned my Solidity from back in the days when I want to deploy a contract to Ethereum chain, the Ethereum blockchain. We have also Remix on Starknet now, developed by my team, Nethermind team. It's very easy to use. I encourage for you guys to try it on yourself. There's even a remote local version for deploy and interact with it, so you don't even have to pay gas. There's Starknet Foundry. For those who likes the Foundry version for Solidity, and there's an equivalent version for Starknet as well. So again, the tooling that you love and often use in writing smart contracts on Solidity, it's already here on Starknet as well. There's OpenZeppelin. Like, how many of you use OpenZeppelin and say that my contract is safe? I'm one. So we have also OpenZeppelin on Starknet now. So there you go. You can mix and match your library templates, and then you can write safe, secure contracts. And there's Explorer. This is one Explorer that I'm working on. Probably I'm showing my own page. We love EtherScan, and we use EtherScan a lot. We also use Voyager a lot in Starknet. Obviously, there are others, but I'm going to mention Voyager for now. So you may ask, like, what's coming up on the Starknet world? We have Volition. Volition is a way to select which data availability layer you want to use. So if you feel that pushing your data to layer 1 is a bit more expensive, there's an option in the future to allow you to push to a certain data availability community. But this is something that is very, very, how can I say, premature. So we'll see it come, but it's not going to be that soon, but that's somewhere in the roadmaps. And there's going to be fee marketplace. And there's going to be the concept of layer 3s. That's why we have things like Madara, open source project. We want to encourage people to deploy Starknet on Starknet so you can then scale or even customize your own layer 3 on Starknet. Gas abstraction for native account is on the roadmaps. It's something I didn't mention. It allows you to pay fees without having native tokens on your wallet. So maybe you can assign like a paymaster to pay for you. So gas abstraction in the roadmaps. And the most important thing, people have been asking, sequences are centralized. So talks and discussions and a bit of research. So I think some of them done by my colleague here, Ashraf. Decentralizing your sequences. So that is under works. So get started now. So this is the QR code that I would like to share for those who want to write some contracts, want to write some constructors, want to write events. How do you use it? One of the syntax. This is the part of the page that I would recommend you to go to because I use it sometimes. I forgot how to declare events sometimes, you know? So this, you just go there and you like click events. So it's at starknet-by-example.voyageronline. Leave it. A couple of few takings follows. Nice. Put it for a couple of seconds. And the end. Yes, there you go. I also put out like QR code for Starknet on Twitter. Do give them a follow. I don't know if you have time for questions, but yes, otherwise, I'm free and available. Just ask me when you see me, bump me around the area.
Thank you very much, Cheechyuan. Let's give him a round of applause. I love how self-entertained he is. You know, every slide he has designed, he has worked on the project, is like seeing his resume. Can we open it up for questions as well? Does anybody have a question? We got one over here. We'll hand the mic over to you. Please introduce your name and your question as well about Starknet.
Hi, this is Wen Hao. Was just wondering what are the costs for Sharp, the shared prover, and also the cost of running a prover for Stone. Open source recently.
That's a very good question. The cost of running a prover, it's very expensive. I don't exactly know how much because I don't run it. I didn't benchmark it. It was recently open source, so I haven't tried it. So, but you have to understand, like the cost of running prover is probably going to be expensive. But we have to understand as well that you only need a couple of like people to run the prover for liveness, but you can never lie when you could generate proof. So lying cannot happen on the proving stage. It's just censorship or maybe liveness. So yes, it's definitely not cheap to run a prover.
Thank you for the question. Anybody else? You want to raise your hand and ask? Got one in front here. We got two. Sorry, got two. We'll pass the mic to each of you. Please introduce your name as well as your question.
Hello, I'm Jeffrey. That was a good talk, thanks. You mentioned using Stark outside the context of smart contracts, like in ML. Can you share some more examples of some activity or projects in that space?
Yes, that's a good question. I think there's a project. I can't remember Alexandra, his name of the. I can't remember what's the open source project for ML again. Giza, yes, Giza, yes, Giza. It's a open source project on Cairo. That's doing a lot of ML stuff. So do give him a check. Just type Giza Cairo. Or Orion, something like that. Yeah, Orion, Giza, Cairo. There you go. Thank you. Thank you. I forgot. Yeah.
By ML, you mean machine learning, right?
Yes.
Smart MC.
Hello, Cheechyuan. Thank you very much for your time on the talk. If I'm not mistaken, you can port EVM contract to the zk environment, correct? So what is the Starknet strategy to onboard more projects and appeal more users for the future?
Thank you for the question. And this is more of a community question. Number one, there was a sunsetted project called WAP, also by my team. So what the WAP does is that you have your Solidity contract. You get to transpile it to a Cairo 0 contract. But it has been sunsetted a couple of reasons. So the strategy right now is to give talks like this, to give workshops like this, try to encourage you, try to let you know, try to advocate you, try to evangelize Starknet, right? Explain to you the benefits so that you understand like why you want to learn Cairo. It has to be the hard way. I cannot like feed you with money and then use the right contract. It doesn't work that way, right? You have to understand why you want to learn Cairo and why you want to deploy Starknet and you love it and then you deploy it. So it's going to be the old school me advocating you, explaining the benefits of you doing it. Yeah. Unfortunately, yeah.
Thank you.
Thank you for the question.
Cairo and Starknet is not EVM compatible, right?
No, Starknet is a chain, Cairo is the language.
Thank you. Any last questions before we close this session? I think that's it. Thank you very much, Cheechyuan. Let's give him a big round of applause.
Thanks, everyone.
Lovely presentation. I love his self-energy. You know, he's always so smiley and so happy as a developer. That's always nice to see. He's very passionate about what he does. Feel free to go and check out other works that he does. You can go and chit-chat with him later and ask more technical stuff, definitely. All right, what's going to happen next is actually we're going to be talking about the state of zk rollups. And this one's going to be a moderated session. All right, we'll just give our team a little bit of time to prepare. Hope you guys have been enjoying the session so far. I know some of them are quite high-level technical. I'm struggling to, keep up, but, we try our best. Nonetheless, of course, if you want to go and check out other sessions as well. In fact, tomorrow, we're going to be talking about a lot of DeFi sessions, about, the world of crypto and in Malaysia, what people are building. So feel free to come tomorrow as well. We've got some workshops going on as well. We've got some simultaneous sessions all the way until 6 p.m. this evening. And don't forget to check out our side events as well. All right. Our team is just setting up our chairs. Now, for this session, we've got 3 guests, 2 speakers and 1 moderator. Our first guest is from Taiko. He was actually speaking earlier. His name is Keng. Our second guest is from Kakarot, zkEVM. We also saw Kakarot earlier. We're inviting Elias. And our moderator is Harith from ETHKL. Okay, let's welcome all 3 of them onto the stage. Let's give them a big round of applause. No problem. All right, one of our speakers is just on the way. He's just using the toilet. No worries. We'll just give him a few minutes to arrive. Hi, Elias. Nice to have you with us. Hello. He's been asking a lot of good questions as well. So now you get to torture him with good questions. All right. Just press the button on the mic. Hello. Fantastic. All right, just give a few more minutes for our second speaker and our moderator to settle in. Thank you all again for staying. I know some of you are here are developers, some of you here are students, some of you here are just interested to learn about what is happening in the Ethereum space, in the zk rollup space. It's good to see a lot of development in Malaysia. We really want DevCon to come to Malaysia as much as we can. So whatever pictures, whatever stuff you learn today, please go and post it on Twitter. Please go and tag DevCon, tag ETHKL, go and spread the word. And the more interest that we can generate in this country. You know, hopefully other people will take notice as well. All right. Let's see, Harith is here. We'll just give Keng a few more minutes. I think he'll just be coming back soon. Don't forget to get your swags as well. I forgot to mention it earlier in the morning. Every booth outside has some swags. Please go and check it out. Yeah, there are some free t-shirts, free stickers, all sorts of nice stuff. Go and check out the booths, go and check out their swags, and get some for yourself. All right.
Can I ask?
Yes.
Who here is a student at Sunway?
Is anybody here a Sunway student? Raise your hands. We got one at the back. All right. Two, okay, two. How many of you are students but not from Sunway? Just students in general. Okay, got one here, a few more here on the left, on the right. Very good. Yeah, we got quite a few. Nice. Keng, come and join us, Keng. Thank you so much. Right in the middle. I'll pass my mic over to you as well. Give me a second. Then moderate. So hurry to. Can you change the slide? One slide I want to show.
To the main stage.
Yeah, then let's take next one.
Yeah, we'll just leave it there. All right. Thanks everyone for joining our panel today. Can I get a quick show of hands? How many people know what a zk rollup is? Okay, and how many people know zkEVM? Okay, cool. So I think there will be some people who are not very familiar. So I think we can jump straight into the panel with that in mind. So I'm showing on the chart, I'm not sure if the panelists can see, I'm showing this very popular chart that Vitalik created a while back, describing different zkEVMs. But before that, can I get maybe one of you and then the other can chip in, just to give a quick explainer about what a zk rollup is. And then the other person can maybe extend that by explaining what a zkEVM is and what the different types are.
Maybe I can go first.
Okay, sure.
Maybe I'll first introduce myself first. Yeah. So my name is Keng. I'm from Taiko, a zk rollup, a layer 2 zk rollup. So yeah, we are a type 1 zkEVM. So as you can see on the chart, there is type 1, type 2, 2.5, 3, and 4, right? So Taiko is right at the top there with being type 1. So type 1 is Ethereum equivalent. That means we don't do any code changes to the core protocol. And yeah, so what this means for developers is that whatever they deploy on Ethereum, they can also deploy on Taiko without any code changes to their smart contracts. Yeah. Maybe you want to add
I
on to it?
guess for those who've not looked at the type, there's somewhat important, a good mental model to build is that type 1, type 2, type 2.5 to some extent, all those three don't require developers to change any line of code. So if they've written, I don't know, a few thousand lines of Solidity to write their protocol, they can just copy paste it from L1 to a zero knowledge rollup. Onwards, so type 3, type 4 requires some amount of change depending on the chain. So this is looking more like zkEVM. But overall, the outlook of the zkEVMs today, so Sprawl, Taiko, Polygon zkEVM, Kakarot, Linear, they target a level of compatibility that enables any dev to just write their code and not worry about the underlying rollup. This is kind of how it should be. And Taiko being type 1 has a bit even more compatibility, is being compatible even with the nodes. This is more like there are many personas, right? There's the dev who writes Solidity and then deploys to a chain, and then there's infra players. So being type 1, you can kind of plug and play Etherscan. You're supposed to be at least able to just use Geth or Reth, which are the software to run a node. So this is nice. And other zkEVMs don't allow for that, but let's say for a dev, it doesn't change anything.
Okay, just to rewind a little bit, because I think we skipped the question about zk rollups. For those who don't know what a zk rollup is and why it matters to Ethereum or just to blockchains in general, can I get maybe Keng to kind of give your Eli 5, explain like I'm 5 answer, or at least maybe 15 for the people here to maybe understand zk rollup if they didn't know anything.
Right, so to know about why zk rollups exist, you need to also know about the other type of rollup, which is the optimistic rollups. So the main difference between optimistic rollups and zk rollups is the proofs, right? Proof being how do you verify if a block is valid or not, an L2 block is valid or not? So optimistic rollup just optimistically believes that all blocks are valid until someone submits fraud proof. Or say, like, for example, oh, I want to challenge that this block is actually invalid, and you will have to compute a fraud proof to argue that this block is invalid. But for zk rollups, we actually validate every single block such that we know that every block is valid. So instead of believing that every block is valid, we submit a zero knowledge proof to prove that to prove the validity of each of these blocks. Yeah.
Yeah, I guess the main attribute of a rollup is to save money on computation. So that's kind of, and then the zk part is you save money, but you don't compromise on security. That's kind of my
So for any degens who spent like upwards of 50 Ether to make your transactions over the last couple of years, you probably understand why rollups matter. So I think we kind of, so Keng mentioned Taiko is a type 1 rollup. So for Ilyas, for Kakarot, like what type would it be?
So Kakarot can target type 2, type 2.5, or type 3. This is really a trade-off on what you want to achieve. So for example, if you're type 1, you can prove L1 blocks, but this is maybe a different activity. So for Kakarot, I think we're going to target type 2, which is essentially you have compatibility and almost equivalence. So you have the same gas accounting, you have the same, you don't compile EVM bytecode, you run it. So you have full compatibility on the language level. You have all the precompiled. The only thing that changes is maybe the underlying data structure. So the Merkle-patch tree that EVM uses is MPT with Ketchak as a hash function. You may want to swap Ketchak out with Poseidon and Pedescent to save money. So this is what Scroll is doing. This is what we're doing. It really depends what you want to achieve. And in the long run, in the short run, in the long run, I would say everyone wants to achieve type 1. Why? Because in the long game is to have this kind of standardization of all zkEVMs. In the short run, we found out that proving Ketchak and all others non-ZK friendly things are very expensive. And so as a trade-off, you're free to roam around the types in some sense. The only type that's a bit harder to roam around with is type 4, because what you're essentially doing, so yeah, for the mental model, type 4 is really you take Solidity and you compile it to your own language. All the other types take Solidity and any other EVM language, Huff, Viper, etc., compile it to EVM machine code and then run it. So as long as you have this, you're kind of free in some sense to roam around and choose your trade-off. Do you want to be cheaper? Do you want to be faster? Do you want to be more equivalent? And all of this comes as a price.
And I think one thing we didn't mention is that you're a founder of Kakarot. So I think a very interesting kind of question to ask is like, what was the backstory for Kakarot? Like, how did it come to existence, and why did you choose to, be this type 2 to type 3 kind of rollup, and why build on zkEVM, which maybe you can explain a little bit more later. But yeah, so like, what's the backstory? Like, how did it end up existing?
Okay, so the backstory is we're almost at the birthday, because it started in October 2022 as a hackathon project in Lisbon, in ETH Lisbon actually. The whole point, and I was new to Cairo as well. I was not so new to Zero Knowledge, but new to Cairo, and the promise was whatever you write in Cairo, so whatever targets the zkEVM as the backend, is provable. So what Chah, one of the inventors of the zkEVM, I think Danilo hinted at it during his talk, but essentially, if you write the instruction set, so if you write the EVM, if you write an EVM in Golang, and then add some RPC, you have Geth, which is the most used Ethereum node. But if you write the EVM in Cairo, what you get is a provable Geth, or like a provable EVM. So whatever transaction you run, so if I do a ERC20 transfer, I can prove it. So this was the dream. It was weird, and the dream was you can create a zkEVM fast without being a cryptographer. This was kind of the promise. And then everyone gathered in the hacker house, and like the hacker house with 80 people, I think. We lived together for a week. I think 7 people were hacking on Kakarot: Danilo, Clement, Fresh Pizza, who to this day remains undoxed. No one knows his name. So yeah, so in 2 months we were able to achieve 100% upcode, and that's kind of my second point. Is the fun part of Kero is it's quite a high level language. It's as hard as it was then. What you're actually doing is, and I don't know if people know Zeth here, but it doesn't matter. But essentially, what you have is kind of an intermediary VM. So you different ways to write an EVM. Like Taiko uses circuits, so their team has cryptographers. Our team doesn't yet. So I would say it's easier in a way to build with Kero and Kakarot. So the backstory is we gathered at a hacker house, we hacked, we saw that it worked. In 2 months we had a working EVM. Then we kind of like solidified from the company and said, okay, let's see how far Kero and this approach of a zkEVM through an intermediary zero-knowledge virtual machine takes us, and go to production with it.
So it's literally been like a year only.
Yeah.
Okay, cool. So next one's for Keng. So you mentioned Taiko is a type 1 rollup. So as Elias mentioned earlier, like a lot of other projects are starting with like kind of the lower types, you know, the type 2, 2.5, whereas Taiko is like going all the way straight to type 1. What was the rationale there for like making that decision, and what were some trade-offs that you had to make?
So actually, the previous the founders of Taiko were actually from Loopring. So Loopring is actually an application specific rollup. So maybe it could be classified as a type 4 or maybe type 4. Yeah, that's not a generalized rollup, but yeah, but so from there we just decided to move on into a general zk rollup, I would say. And why type 1? We believe in like minimalism to the developers. We want them to have like literally zero code changes like when deploying on a rollup. So that's why we chose to go for like a type 1 zkEVM.
And were there any trade-offs that you had to make when you decided to do type 1?
Yeah, so type 1 would mean that we have to cover every single operation, I guess. We have to write every single operation in as circuits to complete the zkEVM. That means the expensive functions like your Kachek 256. We also have to write those in circuits, and this would mean that our provers will have to spend significantly much more resources to prove a single block, I would say. And but this benefits the developer because they don't have to care so much about edge cases. Yeah, so it might seem small, but for example, if your Kachek 256 hash function if your Kachek 256 hash function's replacement actually costs more gas on other zkEVMs, existing protocols that use the existing hash function might actually exceed the block gas limit, causing your transaction to like fail, and so your dApp might actually fail to work on the other type of zkEVMs. Yeah.
Okay, cool. So shifting a little bit, so my understanding is both rollups are in testnet at this point.
We're close to testnet.
Okay, close testnet. Okay, well, still testnet then. So I guess the question would be when mainnet, or what would be the roadmap towards getting to mainnet?
Yeah, maybe I'll take this one first. So currently, Taiko is on its 5th iteration of testnet called Jolnia, up to mainnet, which will be about Q2 next year. We plan to launch with the proto-dank sharding upgrade on Ethereum. In our next testnet, we plan to release like this contestable rollup as part of like a multi-prover rollup. So we want to not only use zk rollups, but maybe we want to try including multi-proofs. Like some blocks could be like proven optimistically, and maybe every 100th block we submit a validity proof. So we don't have to spend so much resources on like submitting zk proofs, and that might like make the blockchain faster, I guess. Yeah.
Yes.
I guess it's always tricky to announce mainnet. Our goal, basically, the steps we need to follow are pass all the Ethereum Foundation EVM tests. So there is kind of a, because the EVM is an instruction set, so you can implement it. But then, since this is decentralized, what is the authority that can look at your execution or code and say, okay, this is an EVM. Like, what makes it an EVM? So my belief is that if you implement all the official tests that all the clients run, but you adapt them to your zkEVM kind of context, when you pass it, you have a working EVM. So you feel kind of safe to kind of go to an audit, go to testnet, go to mainnet. So we're finishing that up now. So I would expect Q2 next year that at least we'll have, at least December, we'll have much more clarity than I can look back and say, okay, I was wrong to say Q2 or I was right. So I will say, I think that I'm right to say Q2 now, and I reserve the right to be wrong.
I think it's Q2 for both next year. Okay, cool.
Yeah, Q2 minus 1 day.
Hopefully.
And then, well, the topic of the panel is state of zk rollup. So I don't want to like zoom in just Kakarot and Taiko. One obvious thing that we see is that right now, when it comes to the actual market, pretty much, I think L2 Beat says it's like 85% of the market is using optimistic rollups. That's Arbitrum optimism base. From your points of view, do you see, when do you see, if ever, zk rollups would catch up to optimistic rollups, and what would it take to get there?
But for example, on the statistics, because optimistic base and Arbitrum have 85% of market share in terms of TVL. But in terms of activity, the top three is Ethereum, ZK Starknet, for example, in terms of TPS. So then arguably you're asking, okay, who are making those transactions? Are they real apps or airdrop hunters? I think part of everything, but you could argue then that other rollups should attract also airdrop hunters. Because Optimism has retroactive funding, so any chain. But so I think that's the first point. So I think Optimist Rollup have the dominion because they've been here first and working first, partially because they launched an EVM and said we will have proofs later, which is kind of really smart because they had a centralized sequencer. They know that everything works, and then people trust them. So I think it was nice. And now, after 3 or 4 years, Optimism has fraud proof, or is going to, and then they will eventually incorporate zero knowledge proofs. That's kind of for the thing. The state of the market is optimistic rollup dominate, but zk rollups are on the rise. And I think the only factor is how fast, how cheap, and how reliable it is. So we've known zkEVMs and even zero knowledge rollups to have pretty bad UX over the past year because the systems were kind of like coming to fruition. And mainly because you cannot launch a zero knowledge rollup and say, I will have proofs later. It doesn't make sense. So it was it's how it is, but I think very, very soon, so in the coming 2 or 3 years, the landscape is going to completely change. We're seeing this because OP stack are all already looking for a proof. And I think it's gonna look like that.
Anything to add, Keng?
Yeah, so like whether zk rollups will catch up with optimistic rollups, I think it's just a matter of time. I think first of all, you gotta have like good dApps on the ecosystem. So I personally feel like why Arbitrum blew up was because of GMX and how it supports like high frequency perpetual trading, and I think that attracted a lot of traders and thus like a lot of TVL. I think on zk Sync era there is a protocol called like Maverick protocol. It's like a concentrated liquidity protocol where you can set like bounds and also helps to shift your liquidity according to the direction of a price. So these sorts of like innovation that help to solve problems and help to make like help to make capital more efficient. I think these are like key factors to attract more users and liquidity to your platform, especially in the long term. Like in the short term, yes, you can come up with like airdrop campaigns and stuff like that. And the success of these campaigns are actually pretty big. Like even like a Galaxy task, which is like a so Galaxy is like a platform where if you complete certain on-chain actions or like follow Twitter, blah blah blah, you get like certain points or when you complete these quests. And actually for Taiko, it worked pretty well. In our third testnet, we launched a Galaxy campaign, and it like caused our user base to grow by like 2 times, which was crazy. That was like 2 times more work for us, like in a short period of time. But yeah, so yeah, back to my original point, it's all about the apps that are building on top of in the ecosystem. Yeah.
Okay, and so I'll just ask one specific question to each of you before we open it up to the audience if we have time. So maybe first for Keng. Taiko's been kind of like talking a lot about based rollup. Can you explain to the audience what a based rollup is and why Taiko is doing that?
So like a base rollup, this term was coined by, if I'm not wrong, like Justin Drake. So basically a base rollup is a rollup where the L2 blocks are sequenced on a L1. And why we chose to do this is also part of our permissionless philosophy. In order to have like a permissionless proposers and block proposers, we need to be a base rollup. And why a permissionless rollup is important is because we want to decentralize MEV. We want to make sure that people can contribute and people can like earn fees from the network and not just the protocol. Yeah.
Okay, cool. And for Elias, so Kakarot's building on top of zkEVM. Some developers have told me that one issue they have with zkEVM is that it keeps changing over time, although apparently that the rate has slowed down. So maybe what are some challenges, if any, on building on zkEVM, and at the same time, what are some benefits of doing that?
Right. I think it's true that there are many breaking changes very often. I was talking to one of the creators of zkEVM earlier, and he was mentioning this trade-off between like stabilization and innovation. So it's hard. So if you look at, for example, the forums on Starknet, people are saying, hey guys, my application broke because one of the API changed in the latest patch or in the latest upgrade. And then right next line, someone is saying, hey guys, why isn't this done already? Like a new feature. So people are asking new features and people are asking for stabilization. So I think it's hard. The challenges for us is that we migrate often, and also we have to think ahead, talk to the teams that are making. So we talk with Starkware, talk with Starknet Foundation, talk with the people that develop SDKs, kind of voice our concerns. What is nice is, for example, Starknet and then zkEVM is able to kind of learn from the limitations of EVM and then build on top. So like good examples were native account abstraction, multi-core, and also this is also not known by many people, but in zkEVM and more precisely Starknet, there is this system of class. So every contract is firstly a class, and then you can instantiate your class. So it means that, for example, in EVM, when you deploy ERC20, that's the standard, every time you deploy the same, so you bloat your chain with similar code. So you duplicate. In Starknet, actually what you do is once you declare the ERC20 standard, and then whenever you want to deploy it, you kind of tell the chain, please, new ERC20. So it's kind of like more lean. So all these innovations come at a cost, which is instability the first 3 years. So we're going through that process. At first, when I started zkEVM, the language looked like assembly. Now it looks like Rust. When we started, the TPS was 0.3. Now it's 100. It's moving forward. It's breaking things. We are annoyed some days. So yeah, the zkEVM dev is very annoyed one day on two, and then the second day they're so happy because we have generic types or like so many things. So, and I'm writing Kero so that people can write Solidity. So in a way, I'm like double brain and like betting on Kero, but also I'm such a EVM moderately maxi, but I think EVM is gonna dominate the space mostly through innovation. So I'd say, yeah, it's a bit of Dr. Jekyll and Mr. Hyde every day.
Thanks. I think that's very enlightening. I think we probably can have time for one audience question. So if anyone has any, please raise your hand. The first one gets to ask the question. All right. I think you have probably answered very well. Oh, okay. We do have one question. Yeah, we can take this mic.
Hello, good afternoon. Thank you very much for your talk. I was enjoying it very much. So listening to you, is there any use case, application, or service that you are more excited about in the future using a ZK rollup?
At least from what I'm seeing, I really enjoy account abstraction on rollups because at least for zkSync and Kakarot and Starknet, they were able to incorporate into the protocol account abstraction. What it means in very, very concrete terms is my wallet uses my phone's secure enclave and not a 12-word seed. So I never need to write somewhere 12 words, and I can never self-rect myself, which happened quite a bit. So this I enjoy, for example. So this is one of the things I enjoy, and I think 4337, so it's the adaptation of account abstraction on mainnet Ethereum, is good, but it's not good enough. So this is kind of what I'm excited about.
Yeah, I think to add on, like account abstraction will open a lot of like doors, especially in terms of like gaming. If you combine account abstraction with low transaction fees, you can actually have on-chain games where users don't even have to realize that they are transacting on-chain, and like with the benefits of decentralization and ownership of assets. Yeah, that's probably what I'm looking to see, not only on Taiko, but like in Web3 in general. Yeah.
All right, so I think that's about all the time we have. Please give a round of applause to the panelists.
Thank you. Thank you.
All right, thank you to our two speakers and our one moderator. We really appreciate an insight into the ZK ecosystem. All right, thank you. All right. Okay, just give us some time to set up the stage before our next topic. Our next topic is going to be a very important topic. It's about auditing. Yes, many crypto dApps, crypto protocols need good, strong audits. And so our next speaker is going to be sharing a little bit about audits and how dApps can get audited and stuff like that. Okay, just give our team a little bit of time to get ready. And if you want to stay back for an audit session, I think it's quite interesting. Yeah? Auditing is very important. Whenever, those days when I was first starting out in DeFi, I always check, is it audited? Is it audited? Is it audited? Who's the auditor? Audits give people a sense of confidence. Yeah. Okay, let me quickly get my notes and see. Okay, 3:28. Oh, we can start earlier as well. Our speaker for the audit session is from Constam, someone named Martinet. I hope I'm pronouncing it correctly. Martinet, are you? Oh, yeah, you're behind me. I didn't see you there. He's already ready. Can we give him a big round of applause as we welcome him to the stage? The mic's over there. You can take it out from the stand if you want. And so he's going to be sharing about, so what is an audit anyway? All right. Martinet, your slides, are they here? Let me double check. Okay. Which folder is it slides? Let me just see. Let me see. Send it to Airtable. Okay, so it should be here. Let me see. Constant. Where's the file? Which one? This one. There we go. Oh, shoot. I closed that. Thankfully. Can I ask my volunteers? Where's Kim? Volunteers, can you ask Kim to help me get the table back? Okay. I know it's here somewhere. There we are. Hey, where is it? Quant stamp. Open. There we go. Full screen. Perfect. Try the clicker. Oh, yeah, perfect.
All right.
All right, take it away. Thank you.
Thank you, sir. And yeah, good afternoon, everyone. So I am Martin Lee. So today I'm going to talk about what is an audit. So it's more of a beginner session. I'll throw in here bits and tips for like developers as well. But most of all, it's like audits 101 and clarifying some misconceptions. So let's go. So a bit of background for myself, Martinet, and then I'm head of developer relations at QuantStamp. My experience, I actually start as a security auditor. So I have audited, well, more than 50 projects from DeFi, NFT to layer ones. Some stuff you might have heard of, including Yearn, ETH itself, so prison implementation, and then Avalanche as well. Our firm did a lot more other stuff. Then I continue to serve as audit PM, standardizing a lot of like different stuff. So kind of like all stack on the auditing side. And so today I'm going to talk about like, you know, what audit is, and audit, spoiler alert, audit may not be what you think it is. And then kind of like from our point of view, what the goal of an audit is. And then kind of like, okay, what's the tip of reducing audit costs and enhancing audit like efficiency, efficacy. So the first thing is, I think when people think about the term audit, then this is oftentimes what's being like popped in their mind, like, oh, financial audit. And, you know, they consider, they link these two terms together, but is it a correct notion? I would say no. And so there's a lot of text there, I know, but we're just going to look at the most important part. So this is kind of like the wiki definition of financial audit. And you can see one thing, the first line is like, oh, it's talking about a financial assessment of an entity as its whole, right? So an entity, and whether it's profit-oriented or not. The second line here is as required by law. That's another highlight I want to have here. Now, the third one here is, well, auditors do consider propositions before them, you know, obtain evidence. This one we can talk about a little bit later. The last one is free from material misstatement, right? So this is kind of like the stuff you think when you're like thinking about like financial audits. Now let's look at it from the looks of Web3 security audit. Still a lot of stuff, but let's just zoom in into parts of stuff. So here, instead of the whole entity, we see it's a part of project defined by the developers, right? And whether it's security, so from profit-oriented to security-oriented or not. So this part seems okay, right? So it's marked in green, but the kind of problem is like it's a part of project, not the whole project. That's number one. And secondly, it was defined by the developers, not someone else, right? The second point is the most different thing here. There is no law that is like requiring people to get audits, requiring them, and then like standardizing how to get an audit, right? So, and it's also kind of impractical. How would you have a law like determine how you're going to implement your code? That's very different from bookkeeping. Like bookkeeping is relatively simple activity, whereas, well, coding is a Turing-complete activity, and that is very complex, right? So that's why it's given a very complex name, Turing-complete. The third and fourth is sort of similar, and this is why the audit term is sort of still acceptable. So we auditors, Web3 security audits, we do consider the propositions that comes before them, which we look at the user document that was, out-facing, and we verify whether those are correct or not. And this is kind of similar, like, free from material misstatement, right? So these are kind of like similar, and that's where kind of the notion of audit works. But the notion of audit don't work is the one, like the point 1 and point 2. So this is one thing I want to point out, the impractical goal of a security audit. If you have this thing in mind, then that's not the correct notion. Like, I'm hiring an expert or experts to ensure there's no bug. If you're a developer, you probably know this is very hard to achieve, almost impossible. So this is really the wrong mindset, and I always want to take the opportunity to generalize this to the general public. What is actually the goal of a security audit? A lot of words. A couple things. One, audit itself is a time-limited activity, right? And what we're trying to do here is to assist the project, assist the developers into finding inconsistencies and vulnerabilities, these two things. And here, the last thing is what you defined of your protocol, right? So this is for the developers. Vulnerability and inconsistency, let me expand a little bit there. Vulnerabilities is like, hey, I have this design. I think it's awesome, it's innovative. And when auditors are looking at it, they say like, this design has flaws because we can exploit it, kind of like the business logic, right? And you don't want this consequence. So that's vulnerabilities, in my opinion. Inconsistency is another big part of audits. So you say you wanted to do it one way, but your implementation is actually doing another thing. As an example, we have previously audited a protocol, options protocol, right? Some people may have background, but options, in simple terms, there are like two types of very different options. One is European option, another is American option. And they implemented European and not the American, but they intended to do American, right? Completely different. But they didn't realize that until we audited it. And this is inconsistencies, right? So it's different because it's not really vulnerable. It's inconsistent. So this is the goal of a security audit. I kind of like to do this visual comparison with some other kind of certificates or stuff that we typically see. So the left one, the left one for you guys is the typical financial audit or bookkeeping kind of stuff. So you have the government and define the scope and define the rules of how you do this audit, right? And you have the test subject and demonstrate these relevant data. And then the auditor then comes in and examine these things, right? So this is how financial audit work. Now on the right side, these are also two common other types of certificates. So the one above is, let's say like a TOEFL test or GRE test or any test, right? The examiner defines the scope and tells you like, hey, this is the scope. And then you show them the data, your ability, and then they will examine, assess the output, right? So that's the upper right. The the down right one is another kind of like certificate. Sometimes we say like, this entity has this credibility, and basically how it does is like, okay, the test subject, there's no external entity that defines the scope, but the test subject just publishes report, publishes data, and then there's like a independent examiner publishes a report based on whatever is published outside, right? But they themselves define and collect the data. So these are all very different, but very closer to our real life, kind of like certificate auditing experience. What audit is in Web3 space is this. The developer team defined the scope, okay? So this is completely different. the developer team define the scope, and auditor accept the scope and assess only that scope, right? So of course there are a lot of like notions that comes out of this. A very simple one is, if I get an audit, does that mean that I'm secure or not? That's something that everyone wants to know, and the short answer is no. And I can translate it in the very simple terms. If I take a TOEFL test, does that mean that my English is great? No, right? Because I need to like see the assessment. That's one thing. Second, if I can define my own scope, then hey, TOEFL test, let's only test my writing ability. And I define the test, I define the scope, and I only take the test that way, and I get a good assessment. Does that mean that my English is great? Not necessarily, right? And so there are like these notions that comes out of this. So that's why we're going back. Security audit's real goal is to help developers, right? It is from the developer, for the developer, helping them to see what flaws there are in what they wanted to see. This is the current state of the audit industry in Web3. So the audit is not being enforced by government. There's no government involved here. The project is the one paying for it, requesting for it. And it's up to the project to publish the report or not, because, well, they pay for it, right? And the third thing is the main goal that I've been keep trying to convey. Audit firms is to present findings to improve dev team's code, okay? We do write as fairly as possible, because we do know that these things can be used as marketing material from the dev team to the general public. And so we do write these things, not only having the dev team in mind, but also like, oh, if they publish this, what notion does it, like what kind of message does it convey? So we are sort of aware of this, and then we are careful about it. But the main goal is always to improve dev team's code. Now, I'm going to the third part, which is actually talking about how to reduce costs for your audits and how to improve the security. But before that, it's sort of necessary to understand what's the auditor's thought process. And this is sort of like roughly, okay? Let's see. So the green part, background knowledge, that is already inside the auditor's brain, right? There's no additional information. The purple part is documentation, comments, and code. This all comes from developer side, the project side. And these, of course, requires the input from the developer. Now, it all goes to a couple things. So auditors tries to do three things when they're kind of assessing a project. They want to understand your intention, the intention of the project. They want to understand the implementation, right? And also, like, just from their background knowledge, they know, like, oh, some of the past attack vectors or some of the common errors that they've seen, those kind of stuff. So they have this like list relevant attack vectors and threat modeling going on. So these are the three things they do in parallel. The ones I listed as kind of like painted as yellow means that it is affected by user or project's input, their documentation, their comments, their code quality. What we try to find after understanding this is like the understanding phase, then there's the attack phase, kind of. Basically, we ask very high level these questions. Does the intention make sense? Because if it doesn't, then, well, there's a vulnerability in your design. Secondly, are there discrepancies between the intention and implementation, right? And this is the inconsistency that I mentioned earlier. Well, the third thing is there's the common attack vectors, and then we just like check against them. This is more or less simple for us, but it's kind of like the learning curve, a lot of things. And all these things compile into findings. But as you can see, a lot of these are determined by or affected by user or the project's input, which is the documentation, comments, and code. Now, as you may have remembered, auditing itself is a time-limited fashion, right? So we think about how much time we need to understand this thing and then attack the thing. So the kind of trick to reduce your audit costs is also simple, actually, is to reduce the time that your auditors need to understand your project, as simple as that. So having higher code quality, documentation quality, better design pattern, coding style, test quality, code readability, and don't do over optimization. These will, make your project basically more readable, more understandable, reduce the time, right? Now, the great news is it is also a way to optimize for security because it's generally just more clear, right? I want to give an example. It might seem ridiculous, but this does happen in the industry. So I've been scoping out a project, and all its variable naming or contract naming are human names, like contract Joseph, and then contract Jennifer. I'm like, okay, so Joseph.swap Jennifer, and I'm like, what? And so just by reading that, you're getting headaches, right? And this goes into this part, the purple part. Don't mess up your code. Don't do these things. This is the ridiculous side of things. Then there's it's a spectrum, right? So the other common misconception is if I write my code so well, you should be able to read my code and understand it. Unfortunately, no, that is not the case. There's different reasons for that. So we need to guess the intention. We need to guess your intention and then read your implementation. And if you don't have a separate documentation or comments or all those kind of things, then we have to guess. We cannot, then there's no inconsistencies to be found. And we can only have guess the inconsistencies. And that makes it harder. So generally these things, I would say, can reduce your audit cost and also optimize for security. Because for the same time frame, we get to understand it deeper and then attack the protocol in more creative ways because we understand it deeper. Now, audit itself is not the end of security. That's how we view it. And this is what I want to if you're gonna take away another message from this talk, this is the other thing. Getting audit itself doesn't mean it's secure, right? And even if you're auditing the whole protocol, it still doesn't mean it's secure. Why? Because the EVM itself may change, right? There could be changes. One old example was that one of the gas, I think for S-load or S-store changed, and then it broke some of the contracts, through the fallback function, right? And that's the EVM part that was changed. And so what you need to do actually, for this, from the security firm's kind of perspective, we consider this a defense in depth. So there's a lot of layers. The ultimate goal is security of users' funds. And if that is our ultimate goal, then there are a lot of things that we can do. And some of the things are actually doable just from the developer side, which is developing using best practices, which we already talked about, which will reduce your costs and all that. You can also do automated scanning and testing. That's a good dev would do. And of course, security auditing is one thing. But after security auditing, there's monitoring and incident response because we don't know what we don't know, right? And EVM may change and all that. That's one thing. Then the last thing is if the unfortunate things happened in those events, you still want to prevent things from happening, at least prevent loss of funds for your user, then there's sort of an insurance, right? So this is how we see it. There is a lot of these layers that we can prevent and enhance our security. Rather than oh, I got an audit, it's secure, perfect. No, this is how we see it. So also gonna quickly talk about the different audit types. So the one that people are more familiar about are code review audits, basically we review the code of the smart contract or the node software. We're also doing infrastructure audits. So basically looking, like right now there are like a lot of like these staking facilities, they run AWS, etc. How is their security posture, right? How are they managing their keys, etc. So this is infrastructure audits. There's deployment verification. So the code itself, although it may be secure by its implementation, its configuration may lead to vulnerabilities, right? I guess it's, okay, that's a little bit different, but I have an example, which is a contract is secure, but it should only be used with a token decimal of 18, right? There could be such a contract. And the team that we interacted, they didn't think about it. And then they linked it with, I think USDC was 8 or 6, right? It's just not 18, and then that messed up the decimals. So this is like where the deployment verification comes from, making sure that you actually configure everything right. Of course, there are like consulting engagements like before the code is mature. For insurance, monitoring, quantstamp, because we're thinking this way, of course, we then offer such stuff. This is still like ongoing. Chainproof is a subsidiary of us. I think the interesting thing for me, at least, is that we are the first legal insurer in this space. I think it's under like some sort of legal framework and then reinsured by Munich Re. So Munich Re is the largest reinsurer in the world. Monitoring-wise, or let's say incidence response-wise, we're partnering with Hypernative. Hypernative is an awesome tool. I would recommend you guys to check it out. A lot of times, what they do, as a dev, I'm actually quite hyped. They have machine learning models, and when you deploy, or when an attacker deploy a malicious contract, they determine that, oh, it may be malicious, and then have an alert out, and then also determine the potential victims as well. And oftentimes that is like 5 minutes before the actual attack happened. So it's pretty cool. In theory, if we catch those and then pause it at that time, then we could have prevented a lot of the losses. But there are obviously like some progress needs to be made on false positive, etc. But at least they have these things, and it has proven like detecting these attacks beforehand, before the actual attack happened. So pretty cool to see them doing that. Yeah, so that's the talk. So there's the contact of mine. Feel free to reach out to me. And yeah, thanks for listening.
Thank you. Yes, indeed. Audits always very important, giving people a sense of confidence. Any questions about audits? Please raise your hand. We'll pass you a microphone. Any questions you want to ask about not financial audits, but rather protocol audits in Web3? Raise your hand. Speak now or forever hold your peace. All good? Or everybody's an expert in audits? Okay, maybe you can ask them a question and then, no, I'm kidding. Ladies and gentlemen, let's give him a big round of applause. Thank you very much, Martinet. Appreciate it. He'll be around. I can just leave the microphone on the counter. He'll be around after this as well. You can go and chit-chat with him if you want to ask a little bit more. There was a time in crypto and Web3, everybody was asking for audit this, audit that, audit this, audit that, proof of reserve, proof of reserve, proof of reserve. I know because I was in a company where we had to go and get it. And the auditor from the financial background doesn't really understand crypto and they gave up. So it can be quite challenging sometimes. All right, let me get the slides ready for our next speaker as well. Okay. Right. Next one. Dimitri, I believe, right? Yep, from Meta Labs. Okay. Google Slides. Let me see. Hold on. Is it this one? Okay, see whether he has a link here. I see. Okay, let me see if I can get you the the link. Did he? Oh, okay, he gave a link. Yeah, okay. Perfect. The clicker is over there. You just give it a quick test.
Which one is better? Maybe this one? Yeah, definitely this one. GM, everyone. Thanks for coming to listen to us. So my name is Dmitry, and this is my colleague Andrei. We work for MATLabs, which develops zkSync era and overall zkSync stack. Yeah, and we came today to speak about security operations. So, and particularly real-time on-chain monitoring tools, as it is very critical, as was shown also by the previous speaker. So, but before we start, I want to invite some brilliant minds who are present here to participate in our code contests. Code for Arena, those are like the ongoing bug bounty program and just security contests that we are running right now. So feel free to participate, not right now, please, but probably just a bit later if you want to win some nice prizes. So yeah, today we're gonna go through the questions that are listed here. And for the first question, I'd like to invite my colleague to speak about it.
Okay. How many of you use the monitoring in your organization? Anyone? Okay.
Yes.
No.
I do. I work in security as well.
Awesome. Yeah. So why monitoring is important? Monitoring is our approach to security. It provides us the big number of the insights for our activities and for adoption of to the threats. So just think about that, and with this idea in mind, I will provide you some insights related to basic threats related to the smart chain and smart contracts area and the blockchains. So there are many threats related to the blockchain and the smart contract ecosystem. I just remind you about several of them. So first of all, this is the private key compromise. You need to understand that your private key is a master key, and if it's compromised, your funds can be easily withdrawn by the attacker, or even the attacker can take the ownership of your wallet and use it for any malicious activities that he would like to do. Reentrancy. So it happens when two contracts interact with each other. So the malicious contract do some specific functions that are vulnerable in another contract. So and use it for mostly for funds withdrawal. Oracle manipulation. So smart contracts are always fed with external data. So, and this data provided by the Oracle. So if somebody can manipulate with this data, so he can manipulate with the contract itself, and this contract might behave in any unintentional way. Denial of service, one of the popular, let's say, and probably the easiest implementation of the attack, when the attacker just overwhelming the contract's functions or resources, so the contract functions are blocked, or just provides the delays with the response. Front running. This is quite a sneaky attack where attacker using the transparency of the blockchain, and he can see when the specific transaction in the queue, and he can put his own transaction before your transaction if the fee will be higher than that transaction that he targeted. The last one, this is smart contract vulnerabilities. So this is flaws in the code which can be used by the attackers to hack the smart contracts and drain the funds or gain some kind of the authorized access there. So what can we do to protect against such threats? Basically, we have several protection measures. So first of all, this is the prevention measures. This is our initial activities and our first layer of the defense. We're using different solutions to implement access controls, to implement some checks, reviews, and etc., to reduce the common known threats. Next, we have detective. Detective measures are our eyes. So using monitoring and anomaly detection features, we can analyze and find the malicious or some kind of unintentional activity in our networks. If the incident happens, so in this case, the corrective measures kick in. So we try to do everything we can to reduce the harm of the incident, to improve our layer of the defensive, and to update our approach and security response for the future. We marked incident simulations and response in the between of the protection, detective and correction, because it's like a breach, because it provides you the ability to simulate the attack without any real harm. So you can identify your flows, you can identify your problems. Based on that, you can make your own response and corrective measures for the future. So if such attacks will happen. So, and yeah, basically in this presentation, we mostly concentrate on detective and corrective measures. The main idea is that one of the measures cannot protect you against every threat. It can enhance one part of the security of your product, but it cannot protect it. Yeah. So the main point here that multi-layer security should be created by design. And just imagine that imagine it as a Swiss cheese. So each layer is a slice of the cheese. It has holes where the threads can go through. So, but when you stack everything together, there are not so many possibilities that the thread go through all holes and will become as an incident. So the idea is to create as many layers as possible. So to achieve that, you need to think, to start thinking about security in very early, even it wasn't rolled out in the production. So just also note that human errors happen. The bugs can be found, and the most interesting part when the bugs and the human errors happen simultaneously. So you need to understand what to do in these cases. There is no way to avoid it. This is the main point that you should notice. So why it is important? In more than 10 years already, right, in crypto industry, there are many tools appeared in the helpful tools that provides us visibility of the chain, that help us to identify and monitor networks, products, and projects. So, but still, we see that incidents are happened, and most of the incidents, alerts, happens within the huge delay. So let's review several hacks from the previous. One of them, quite recent one, is for the CoinEx. Another one related to 2017, it was the Parity Wallet, multi-sig wallet hack. So, does everyone knows about that hack? So, do you read about that or? Okay. So basically, CoinEx hack. CoinEx is a crypto exchange, and this hack started from the private key compromise. First drain around 5,000 ETH was done in the middle of the day into 3020. All times stamps will be mentioned in the UTC time zone. So if you read some articles in the internet, it might be some different times, different with my presentation. So I just use UTC time zone. Basically, this drain very large, right? So, and if the company would have the monitoring system in place, this drain will be monitored and alerted to them. But nothing was implemented. So, and then hacker did different withdrawal using other cryptocurrencies. So like BTC, Tron, Ripple, and still those transactions are quite high. After 24 minutes from the first drain, the crypto security company, Cybers, they tweet an alert about these transactions, and they tag the CoinEx account, official account there. And only after 4 hours from the event, CoinEx responded and made the suspension of the withdrawal. So the main idea here, so if the company would have the proper alerting, they couldn't mitigate or block the first withdrawal, but they could mitigate the next withdrawals that lead to around 70 million lost of the company. Next, it's quite an old one. This is Parity multi-sig wallet hack, July 2017. So this vulnerability was identified in the multi-sig wallet versions 1.5 and later. The attacker used this vulnerability to drain 3 wallets. I don't know, I think 3 wallets, right? So the first one was done on July 18th on 10:30 in the evening, approximately, and other 2 was done after 13 hours from the first one. So the main point here that the owner of the second wallet identify that their wallet was drained after 4 hours. So they check the attacker's address and they saw that these high transactions also hit that account. So they did a notification for the Ethereum Foundation and many developers groups about this issue and about this problem. And this group identify the vulnerability of the multi-sig wallet code. Here, the great example when the monitoring or alerting from one team could help the community, the crypto community in total. Because for this decentralized attack, because to help to save the funds, the white hat group did the same hack for more than 590 wallets that were vulnerable, and they saved around more than $81 million for the community. So yeah, they did an identification about that after they finalized it. So, and everyone could claim their funds from these saved wallets. Meanwhile, Parity team did the update of their contract and they fix the vulnerability. So in the end of the day. So once again, as we mentioned right in the beginning of this conference, that we are making the community. So, and alerting is not the, let's say, only the problem of the one company. Alert should be available, when monitoring should be available and done by every company. So, and these feeds and information should be shared between the community. So that is how we can reduce the number of the hacks and reduce the numbers of the stolen activities. So, yeah, I will provide the microphone to Dmitry. He will provide you details about what to monitor and how to monitor and what tools can be used.
Thanks, Andrei. Yeah, so basically, as was mentioned, I just want to add a couple of words to the previous slide. As was mentioned, the community effort is very essential, and it builds the overall trust in Ethereum, in crypto, and helps the adoption. That's why building the proper monitoring in your company, in your project, you would contribute to the overall security of the community. Yeah, so now let's speak about what we should actually looking for. So basically, it's all sort of the anomalies. So first of all, it's amounts. Amount of transactions and transactions amounts. Yeah, so because someone can be just drawing lots of funds from your contract by bypassing some security limits with tiny transactions on gas fees, for instance. Or, for instance, you find out that someone just deposited a huge amount. Yeah, so your TVL grows dramatically. So maybe it's money laundering. Yeah. So next one is the transaction times. So imagine that you have script that, I don't know, equalize the balance between the contracts, just sends money from your hot wallet to your cold wallet. And this happens, let's say, every hour. And at one moment of time, there's a random transaction going to, let's say, the same cold wallet. An attacker just tried that the private key he compromised worked. It can be nothing. It can be done for a good reason, but it can be also a bad reason. These, anyway, have to be noticed and checked. Transaction participants and actually governance events participants. So let's say you have some spread with Shamir cryptography, for instance, or a multi-sig for voting. And for instance, you usually use three or five, yeah? And those three people are pretty much permanent, yeah? So the rest are the backup. Imagine that three of them, two backup persons would be hacked. and the attacker can just use your backup against you. So if there's an unusual voter participating in the process, you should note that and just be sure that it's fine. And the transaction details. We saw actually a few events when the attackers and the code used a different transaction type, like legacy type, type 0, and type 2. And this is the technical side of things that is usually missed. You still should be very precise. So make sure that you determine what is the normal transaction for you. Smart contracts themselves are a bit different. So additionally, there are some common approaches right now to develop and to have certain governance events. Usually it's based on Open Zeppelin templates, for instance. What you should look for is the proposal creation, actually key governance events, I won't read it. And any significant events for your contract. So if someone is minting your tokens, this is like, you should know about that, right? If you don't have monitoring in place and you didn't do this, how you can know? Only with monitoring. So now that's all cool, right? But what we can do with that? Because like building own tool set is quite complicated, but let's first of all check what we should keep in mind. So first of all, it should be separated. What it means? So just remember that your infrastructure can be hacked. And when I say infrastructure, I mean your computers, your servers, your phones, it can be hacked. And if you run the monitoring toolset on the same infrastructure that your project is running, then attacker can just turn it off. It also means that if you are large enough and you start thinking about the insider threats, or for instance, you want to consider the threat of a person being compromised in your team, kidnapped, for instance, then you should also separate the teams. Your monitoring team, the team who can configure the monitoring and have access to modify your monitoring, should be separate from the team having access to your normal infrastructure. Otherwise, there will be additional attack vector. So it has to be reliable. Monitoring is not a vital part, but a critical one. So at least it should not go down without you noticing that. So have monitoring for monitoring. Very tense, right? Remember to document why you implemented some monitoring. Have the configuration somewhere in Git, for instance, and test your monitoring and test it again. As mentioned by Andre, there are actually many ways to test it, including the simulation scenarios, but we will talk about that a bit later. And so what tools can help us to achieve that? So I'm here just talking about our experience, so what we use in Metal Labs, how we build the monitoring for us. So first of all, it's API of the smart contracts, of the chain, of our zk Sync Era API. Second is the Open Zeppelin. Open Zeppelin is a great tool, or we will speak about it a bit later. There are some alternatives to them as well. yeah, so these SaaS monitoring tool sets allows you to configure many things in few clicks. Yeah. GitHub, a free way to store your configuration. They have actions. You can, in many ways, just deploy your configuration in few clicks, and you can configure it separately from your infra team. Portabots. Portabots is a huge step forward. So this team actually built quite good, reliable solution for monitoring. Unfortunately, they don't currently support zkSync era, but hopefully it's gonna come soon. But for now, the major use case for us was monitoring the L1 part for our ecosystem. And Grafana, Prometheus, and other tools like PagerDuty, I don't know, Ops Genie or whatever escalation and incident management tool you are using. Yeah, so about the Open Zeppelin, as I promised, there's a separate slide. So they fully support zkSync. So Open Zeppelin overall is the MATLAB's partner for the security solutions. And we work with them very closely also for the security audits. So what the product does, it monitors basically all the events happening on multiple chains. You can filter out and put some logic inside. It can be a simple one. You can also integrate it with the portabots if you need some advanced logic. Then it can just escalate to your PagerDuty, Ops Genie. It also supports webhooks and so on. And if you are not very techy, they have GUI, which can help to configure the basic configuration just in few clicks. So overall demo of the product is available from this QR code. If you don't use them, I highly recommend you to just check it out. And the Defender has actually a lot of other cool security features aside of monitoring, like deployment of the contracts, blah, blah, blah. So just check it out. Yeah, so in order to give you a quick start, I've prepared some basic, very basic sample of the code. It includes the GitHub Actions, which can deploy the configuration. It includes the very simple ERC20 token, and it gives you an alert to your email. So yeah, but you can easily just kickstart from there. So, okay, we detected it, yeah, so we received an email. So what we gonna do? Just imagine your engineer receives a call in the middle of the night. Okay, private key is compromised. What? I wanna sleep, yeah? So be prepared. It's a very simple answer. So think about the key attack scenarios and possible response that you want to have in a predictable way. Write it down. It's very important because in the middle of the night, under a huge amount of stress, people make mistakes and they do need notes. And test it. And test it again. Actually, the real life exercise with the limited knowledge, like simulation of the hex scenario, improves the incident response a lot. But I can tell you for sure, you won't make friends like in that way. A small heart attack is still a heart attack. And I can tell you, as I was the participant of one of such exercises in MATLABs, but I was not aware. Yeah, I was thinking to resign even. but it goes away after the stress is gone. Yeah. So and identify a document how you're gonna mitigate the most significant threats. Like, what are the conditions under which you want to pause your contract, or you want to implement additional delay. Maybe you want to even automate part of that. Like, if you get the alert, a script is executed, then publishes the pre-signed transaction to pause your contract. This will help with these scenarios that Andrei demonstrated, like with hours or like between the first withdrawn money and the actual incident response. So, well, so what's next? Yeah, so we are going to the decentralized world, and all the tools, nearly all the tools that I mentioned are pretty much centralized, yeah? So, to be honest, I don't know the answer. And if you know what to do, so I have some ideas, like creating a DAO with the cool security people who stake their reputation there and actually do the community response to the incidents. It can be a case. So let me just invite you for some discussion. Yeah, so if you have ideas, please feel free to share. Yeah, we are available somewhere there. Okay, thank you.
All right. Thank you very much, Dimitri and Andre from MetaLabs, talking about a very important topic about real on-chain monitoring. It's indeed very important for anyone developing any protocol. You never know when hackers might come in and sneak away with your funds, so always have to be careful. Okay, I quickly open for any questions. Anybody have a question? Please raise your hand. Just wait for a moment, guys. Anybody, feel free to raise your hand. No. What do you think was the worst hack in crypto so far? The most terrible hack? Oh, it's switched off. You can switch it on. Just press the button there. Is it there? The worst, what in your opinion was the worst hack?
I can definitely tell that the one when I had a mini heart attack.
Oh, okay. So that one was a test, right? Someone was testing your system. Okay. Okay, that's good. So everybody go and test your systems tonight. Just don't tell your developer and see what happens. All right, otherwise, let's give them a round of applause. Thank you, gentlemen. Dimitri and Andre. Yeah, oh, where's that sound coming from? Oh, okay. Yeah, I also work in the security field, so I always want to remind people, please be very, very careful. Every single day, I handle scams and hacks from all around the whole world, and I always have to tell people that you have to be very, very careful, okay? So don't click on links, don't click on random message that promise you returns, you know, they're all fake. Please be careful, especially in crypto. They target a lot through Telegram, through Discord, through social media, and anybody can kena. Doesn't matter who you are, everybody can be vulnerable. So please always keep your funds safe and keep your devices very, very safe as well. Don't simply click on links. That's the number one way people get scammed. In fact, in my industry, we have noticed a very scary thing. It's a piece of malware that infects your device. And the malware, you won't even notice it. What happens is that when you copy an address, a crypto address, it will detect that you have copied a crypto address, and then when you paste, the address will change. Yes, so I've seen, I don't know, have you seen this before? Some of you have seen, I can see you nodding. So I've seen this in my workplace very often, fooling customers, because customers, they just copy and they'll paste. Who checks, right? Not many of us check. Sometimes you only check the last 2 or last 3 digits, and sometimes the scammer's address is exactly the same. It's called a vanity address, so they can mine addresses to look like your address. So it's very dangerous. And then the malware is in your device or your computer, and you don't know it's there because you just copy and paste. Suddenly, the pasted address changes suddenly, and then you withdraw the funds to the scammer, and then you can't reverse it. So that can happen as well. So please be very careful. That's possibly one of the scariest hacks and scams that I see on a day-to-day basis. So always keep your security settings up to date. Always keep your, if you have whitelisted addresses, use whitelisted addresses so you can always go to the same address. Don't use random addresses all the time. Okay, whitelisted is actually quite good. Okay, anyway, just a quick reminder, since all of us are in the industry, always good to remind about security. Our next topic is from Nethermind. It's about Nethermind client and optimizing Nethermind's sync time. All right, our speaker is Ashraf. We're going to welcome him to the stage. Ashraf, where are you? Can you wave your hand at me? Oh, there he is. Let's give Ashraf a big round of applause. All right, he's going to be speaking about Nethermind. You give slides, all right? Okay, I'll get the slides ready. Just get your slides ready. This is about the Nethermind client. This is our second last session for this evening. After Nethermind, we've got a consensus layer on Ethereum. Okay, let's see. This one, right? Yeah, there we go. Okay, your microphone is over there in the clicker. You can just test it out. Okay, our second last session for this evening, all the way from Nethermind. Ashraf, the stage is yours. Take it away.
Hello. All right, it's working. It is working. Okay. Assalamualaikum. Hello. My name is Ashraf. I work for Nethermind as a core dev team. So I'm an Ethereum core dev, meaning that I work on the Ethereum client for Nethermind. So what is Nethermind? So Nethermind is the second most popular Ethereum client. So everyone knows about Gas. Gas is this guy over here, which is the most popular one. And right behind it is Nethermind. And according to Ethernodes, it's around 30% market share. I think it's on Monday or something. This is Ethernode. Ethernode is not very accurate. There's some, something about it that people talk about. But yeah, next is Nethermind, roughly. So why is it important? It's important because of client diversity. It's important for client diversity. Ethereum have a lot of client, different type, and there's Aragon, there's Gas, there's Rest, and everything else. And then there's also Nethermind. So why do people use Nethermind? From what I heard, is because of its sync time, which is faster than Gas, and also because apparently, if you look at Reddit, it's because of the attestation performance, which is usually higher than other clients. That's why people switch to it. So I'm here to talk about the sync time because a lot of the time I work on it, right? So I work on it. I used to work on the merge, and then after that, usually bug fix and also the sync time. Right, so there's a lot of optimization at the sync times. So sync time is important because it makes it easier to switch client, right? If you try to switch to Gas, at least for me, it will take around 6 hours to sync. But for Nethermind, it will take around 3 hours, which is half of the time. And there's a lot of reason for that, but it's largely because of engineering decision, in my opinion. Gas focus a lot more on efficiency, and Nethermind focus a lot on throughput, meaning that if you still have some SSD bandwidth, it will use all of it as much as it can. And sync time is important because of many reasons. Aside from the easy barrier of entry, a slow sync is also essentially a hanging sync, meaning that because the chain is keep moving, if the sync is too slow, it will need to do more work in order to catch up with the network. So you need to have it to be reasonably fast. And also it's because it makes it inspiring confidence because Nethermind have a 95% sync rate. The definition of sync here is a bit, it depends on how Ethernodes interpret it, and it also make development easier for me because I don't have to wait 6 hours, so I just have to wait 3 hours or something like that every time I need to change the database configuration or something. So if you look at the sync rate over here, Nethermind is, that the statistic for the one that is sync, Nethermind is actually really close to Gas, like 38%, and Gas is 39%. So, at last week, that's like 5 minutes of time where Nethermind have a higher percentage than Gas according to these metrics. So it is pretty close there. This is more statistics. So we have Nethermind at the highest sync rate. The definition of sync is a bit blurry. And that's Gas at around 60% and the rest. So this is a graph of the sync percentage and also the Nethermind's market share, which is around the blue and the yellow line. As you can see, around the merge, the sync percentage goes up to around 95%, and the market share also goes up. Last week, there's like a big jump in there. So we are at around 35%. It's actually go down a bit. So actually, when it actually goes up, what happens is like gas goes down a lot. Like there's 100 or so gas node that goes down, and when it goes down over here, there's like 100 or so gas node that actually goes up. So the percentage is not, it's a bit flaky because of gas. This is in terms of the absolute number. So as you can see, Nethermind is still going up. I don't know until when. I thought there would be like a little stop over here around 30%. But then again, last week it goes back up. So I don't know, you guys are still switching to Nethermind. So pardon the impeccable handwriting. So this is how, sorry, let me just, there we go, much easier. I'll just stand over here. Right, so this is roughly how Nethermind sync. And this will explain what does it mean by sync rate over there. So actually, Nethermind does not sync from Genesis. It sync from a block that is close to the head. We call this a sync pivot. And from there, it will, once it's sync close enough, it can start snap sync. So snap sync, and after that, there's a snap healing, because snap sync, which is downloading the trie that is required for the block processing, actually doesn't download the trie completely. So there need to be a small phase called snap healing. And this whole phase, after this, Nethermind can process block. So at this point, Nethermind is essentially following the head. It can return the new payload message correctly to the consensus layer. However, it has not downloaded all of the blocks and the receipt yet, and that will take another two hours. And another difference from Gas is that Nethermind doesn't actually download all of the blocks and receipt. It only downloads it to something called the ancient barrier, which is around block 12 million or something, roughly that. So which is the block that is starting required for the consensus layer to work correctly. So the whole process takes around 3 hours if you have a setup similar to mine. And this first phase before the start of the process block will take around 80 gigabyte of bandwidth, and the rest will take around 500 gigabytes of bandwidth. So so there's a lot of improvement over the years on each of these phase. The first phase, which is the fast sync, which is the traditional fast sync, but we don't actually start from Genesis. The sync pivot used to be configured inside the sync config, and recently it was changed so that the sync pivot will be get from the consensus layer. The consensus layer will call Nethermind periodically for what it thinks is the best, what it thinks is the canonical block and the finalized block and such. So it used to be configured manually within the sync config file. So what happened is usually is that people will notice that older Nethermind version take longer time to sync. That's because the configured trusted pivot is actually older. So it needs to take more time before it can start snap sync. Nowadays, it's no longer an issue because we just take it from the consensus layer, and it will only need to download around 60 block or something. So it will take like 1 minute to complete it. Assuming that the consensus layer already sync, which is depending on how it is synced. Something usually it's a checkpoint sync, so it's like, I don't know, exactly 1 minute or so. And after that, we have the snap sync phase, and there's a lot of optimization done on this part, because this part is the most processing heavy part of the sync process. So the two most, I guess, important part before is on this part, which is a 5342. And what happened before, a few versions before, is that Nethermind still have bandwidth, still have processing power, but it doesn't know what to do exactly because it's blocked by a certain request which is not parallelized. So this change just parallelized that and just split the top level address range into 8. And this cut down the sync time from roughly around, how much is this, 45 minutes or something, down to 35 minutes or something like that. Right. Another big improvement is that a sync DB tuner, which is nowadays enabled by default on 1.21. So what happened is that during syncing, Nethermind will change the database configuration a bit so that it will be write optimized. It sacrificed a bit on the read performance, but because SnapSync is very largely just writes and very little reads, this reduced the overall sync times quite dramatically. So the overall bytes written is around 30 to 40% reduced, and this cut down the rate of the writes from roughly, how much is this? 60,000K, 600K nodes or something to roughly 1.5 million nodes or something. So it really depends on the SSD and the processing power, right? In this case, it's about 30 minutes, slightly less than 30 minutes for the SnapSyncs. Yeah. So SnapSync so it's very close. So this is what happened. This is probably what it counts as sync, right? So that's why the sync percentage of Nethermind is quite high, because it only takes around 40 minutes or so for this particular phase to complete. And at that point, Nethermind will return a status code that's saying that, yeah, our latest block is definitely close to it, because we are processing the block and such. We just don't have the rest of the blocks to respond to RPC. Another thing is that concurrent read and write during state healing after the SnapSync, because SnapSync doesn't produce a correct try, so it cannot really process the block, right? So previously, it turns out that the read and writes for this particular phase is behind a single lock, so it cannot be parallelized. And if you try to benchmark SSD before with a single thread, the maximum IOP is around 12.5K IOPS. So it's not like 1 million IOPS that the manufacturer usually advertise, right? So this changes that to use a read-write lock, and it can parallelize the read by quite a lot. And after this phase goes down from around 50 minutes to 2 minutes, typically on a fast SSD. And this particular phase is quite important, because if your SSD is slow enough, essentially you cannot sync, because it will have to do more work if it's slow, right? If it goes too long, then it will need to find another try and restart the whole process. So that's why if you go to the support page of Nethermind, some people finish this in around 15 minutes, another people take overnight to resolve this, because of it needs to catch up to the network, right? So this changes that, so that it's no longer become a bottleneck. And then we go to the next part, which is a fast block. And this is also another recent change enabled by default on 1.21 also. And previously, the process of downloading the blocks take a huge amount of write bandwidth of the SSD. This is largely because of database compaction. Because of how RocksDB works, there needs to be some kind of compaction happening. And this changed that by basically just enabling a feature of RocksDB called blobsDB. And this cut down the total writes by about 5 times. So that's why you see inside the release note of the latest version, there's saying that in some configuration, it reduces the sync time by about 5 times. It depends if you are limited on the SSD or not. In my case, I'm not very limited on SSD, so it doesn't change that much in my case. And another difference is the fast receipt, which is done before the previous changes. That's why you see it doesn't consume much bandwidth over here, even though that the database of receipt is actually quite large. It's probably around 100 gig compared to blocks, which is 300 gig. Right, so the changes is actually quite simple, which is just to prefix the key, the RocksDB key, with the block number. So this trick, which if you look at the database design of Aragon, which Aragon does for every database of it, actually reduces the compaction by quite a lot. So this reduces the bandwidth, the total writes for the receiptsDB phase by about twice or something. But this particular phase usually is limited by the CPU, so it probably doesn't make much of a difference for most people. And yeah, I guess that's it. That's all in my presentation. So what's next for Nethermind? That's Cancun and all of the protocol level stuff. There's also a flat DB layout, still working on it. I'm not sure. It's a very problematic system, and there's some other things that I'm thinking of doing. Yeah. So that's it.
All right. Thank you, Ashraf. Speaking about the Nethermind client and the upgrades and all that, anybody got a question about Nethermind? We got one here. We'll pass the mic to you. It's just coming in a minute. Please introduce your name and your question.
Hello, I'm Wei Han. So I wanted to ask regarding the snap healing process. So my understanding is that because it's trying to keep up to the network, that's why you have to do some healing on the outdated try nodes in the try. So what happens if, let's say, a small or a big reorgs happens in this case? Would it affect, if my understanding is correct?
The main point isn't really to catch up with the network. The main point is that after the snap sync, the try is not correct because different part of the try comes from a different block. So it needs to finish it. And state sync, the head must be from a canonical block. So it picks a try from the canonical block. That's how it prevents that issue.
Okay, I think I also have my second question, which is on, let's say if we were to compare GEF and Nethermind. So for my understanding from the very nice handwriting that you had.
Impeccable handwriting.
That basically Nethermind, it feels like the architecture's philosophy is that, let's say for GEF, if I remember correctly, for SnapSync, it will download all the blocks, download all the data that is not needed to process blocks. But for Nethermind, is that, okay, what do I need to process a block, which is just the try, the updated state, right? So once you have the complete state, then only you download all the so-called unnecessary things that needs to so-called keep up with the network or to continue with the network. So is my understanding correct in that sense?
Yeah. More or less.
Okay.
Yeah, that's
Really
that's
straight
a
to the
lot.
point answer. Yes.
There's quite a lot more different than that. For example, Nethermind doesn't download all block, right? So it download from the ancient barrier, which is block 12 million or something. So if you want something further, you have to change the configuration so that it downloads that also. Another difference is that GAS has an what we call that ancient database, right? And the restriction of the ancient database is that you must insert the blocks in a strictly increasing order, right? And the problem with that is that you have to reorder the block somewhere in the memory or something, right? So that's a sacrifice they have to make. And if the memory buffer is slow, they have to throttle it down, right? So Nethermind doesn't do that. Nethermind just dump the whole thing to the Roxby and let Roxby do whatever it needs to do. That's different.
Okay. If anyone doesn't have any question.
Are there any questions? No, it's all yours. Go ahead.
Okay. GEF also has they recently upgraded to PebbleDB. So is there any plan? I mean, do you think it makes sense for Nethermind to upgrade to PebbleDB in the future?
If there's a binding, it might make sense. So it makes a lot of sense for GAS to upgrade to PebbleDB mainly because LevelDB previously doesn't have a concurrent compaction, and that really limits their write rate. So that's another reason why GAS might be slower. But another different reason is that PebbleDB is kind of like RocksDB++. You kind of can make RocksDB as fast as PebbleDB, but you have to tune it quite a lot, and until a certain point where you don't really have a choice but to switch to PebbleDB. But that point is quite high. So does it make much sense for us to make a C# binding for PebbleDB to, have a write limits higher than 1.5 million keys per second? It doesn't make much sense if you ask me.
Okay, understand. I think my last question here is not technical related. Just want to understand more about yourself. Is that because I previously talked to you before, but what's the difference between building a distributed system in blockchain space versus, like, let's say, in the traditional Web2 space? Yeah.
I think the main difference is that with distributed system like this, you have to validate every message. You have to validate every single message in one way or another. In a distributed system, in a big tag, you don't have to do that. And this actually add quite a lot of overhead. For example, in my development setup, I have 4 gas nodes running locally, takes up 70 gig of RAM, so that I could saturate Nethermind. And why is it 4 gas nodes instead of 1? Because a single connection have a limit to how much bandwidth it can because of the RLPX decoding. Because we need to encrypt the connection. So now there's a limit over there. So that's probably the biggest difference in terms of networking.
Okay, any other questions? Feel free to raise your hand if you want to ask about the Nethermind client, or any of the upgrades, going once, going twice. All right, let's give our speaker a round of applause. Thank you very much, Mr. Ashraf. I'll be honest, the only word I understood was HDD. It's all good. Okay. Okay, we're going to take a 10-minute break because we ended 10 minutes early. So a quick 10-minute break, use the toilet, and then you can come back for our final session. Our final session is on the consensus layer. So we can find the slides. Are the slides here? Consensus layer and Ethereum. Okay, come back in 10 minutes. Yeah, 1 second. Where's our... go ahead. Oh, Nishan, is it? Nice to meet you. I'm Ross. Pleasure. All right, please come in 10 minutes. You can just stay for a while, just a few minutes. So we're getting the slides ready. Our final session for this evening at JC1. Final session, we're going to be learning about the consensus layer and what we can be expecting from future Ethereum hard forks. Yeah. All right, it's been a long day of very technical sessions. Tomorrow is going to be DeFi sessions, which I'm looking forward to. What to expect in the consensus layer. All righty. Oh yeah, can. Why not? Product placement.
Is there another? You can test the.
All right, ladies and gentlemen, our next session is about to start. Come in. I can see people making their way in, coming back from the toilets. All right, just test your clicker, Nishan. Make sure it's nice and. Yep, you can pull it out. Just pull it out all the way out. Yep. Clicker is working. Let's see. Just the big circle in the middle. There we go. Perfect. All right, ladies and gentlemen, we're going to be learning about the consensus layer in Ethereum, and our speaker is Mr. Nishan Das. Let's give our speaker a warm welcome. All right, the stage is yours, Nishan. Take it away. Thank you.
Right. Hello, everyone. Today I'll be talking about what we can expect from the consensus layer in the next hard fork. So some background, I've been in Ethereum core dev for many years. So I've been working on the Beacon chain since 2018. The merge, and now 4844. So I hope by the end of the presentation, you guys will have an idea of what to expect on the consensus layer, and also what rollups can expect going forward. So this is a small history of hard forks in the consensus layer. So in December 2020, we had phase 0, which is the Beacon chain genesis. So that is when the deposit contract was deployed. You had all the validator deposits go in, and the Beacon chain finally launched. In October 2021, you had AltLayer, which was the next hard fork. So this actually brought in light client support for Ethereum. So what this means is that you had a new construction on chain called sync committees. The sync committees allowed a subset of validators to attest to a particular Beacon block root. And using that, you can build light client proofs. So light client proofs can be used by many applications. Some would be, cross-chain bridges, or people trying to build trustless staking pools. September 2022 was the big one, which was Bellatrix, or better known as the merge by everyone else. The merge was in progress for nearly 1.5 years, I think. We were testing it for the last 7 months of it, to launch on 2022. And the last hard fork that we had was on April 2023, called Capella. So Capella was a hard fork that enabled withdrawals and allowed validators to actually access their funds on the execution layer. So today I'm going to be going through all the EIPs that are going into the NEB. So I'll just go through them. So EIP 4788 is Beacon block root in the EVM. EIP 7044 is perpetually valid sign of voluntary exits. EIP 7045 is increasing the max attestation inclusion slot. And EIP 7514 is adding the max epoch churn limit. And finally, for the start of the show, EIP 4844, which introduces shard blob transactions onto Ethereum mainnet. So starting with EIP 4788, so what this does is that this allows the Beacon block root to be accessible by in the EVM. So any contracts on the execution layer can actually access this value. So what this is basically commits to the hash tree root of the Beacon chain, and you can use a corresponding execution payload header to know what was the past Beacon block root. So what is the main motivation is so that applications have access to consensus layer state. So if you're an application and you're building a staking pool, you would need to know the Beacon chain header, Beacon chain root, so that you can actually derive stuff like validator balances, validator status updates, and also if you're building a cross-chain bridge, having knowledge of what actually is the finalization checkpoint is very important, because using that you can choose to mint, burn, or redeem funds on either side of the chain. So yeah, what I described. So yeah, moving on to the next one is EIP 7044. So perpetually signed validator exits. So this allows a validator exit to be perpetually valid from Capella onwards. Currently, validator exits are only valid for 2 hard forks. So if you're a validator and you want to exit participating from the chain, you can't just stop attesting. You basically would have to sign a voluntary exit in order to exit from the chain. So the main reason that we are trying to actually introduce this EIP is so that it improves the UX of actually creating a voluntary exit. So right now, staking pools have separation of hotkeys and withdrawal keys. So what could happen is that if you have 2 hard forks on the line, and the individual that actually possesses the hotkey, they can actually grief the individual possessing the withdrawal key by not signing a new voluntary exit. So you could have funds stuck perpetually in the consensus layer. So to prevent this UX degradation, we allow perpetually signed voluntary exits to be valid for all future forks. So yeah, like I mentioned earlier, you have staking operations where one party holds the withdrawal key, the other holds the hotkey. So you'll only now need to generate signed voluntary exits once. And yeah, okay. We can move on. Okay. So this is the next EIP, EIP 7045. So what this does is that this increases the max attestation inclusion slot. So right now, if you're a validator and you produce an attestation on chain, you basically can only have your attestation included in 1 epoch or 32 slots. So while this was fine when the chain had 16,000 validators, currently right now on mainnet, we are running close to 900,000. So there is a lot of activity on mainnet, and if your attestation is slightly late, there's a good chance it'll be completely missed on chain. So if you basically can extend this, what happens is that you can have late attesters have their attestation included on chain. So instead of being penalized, you get a slight reward. And one main reason that we're actually adding this is that for LMD Ghost, which is the fork choice protocol that Ethereum uses, having a rolling window of 2 epochs for attestation inclusion, it is pretty important in order to generate a security proofs for it. Also, consensus researchers have been working on a confirmation rule for the beacon chain. So what this means is that instead of waiting for a finalized checkpoint to determine whether you can regard this state as completely finalized, you can use a confirmation rule which tells you that in 4 slots, under assumptions of on a certain amount of honest stake or network synchrony, that the chain will not be reorged. So for that, we do need increased max attestation inclusion slot. So yeah, like I mentioned earlier, if you're missing a later attestations, now you have a larger window for it to be included. So the average validator would have a higher profitability because with these missing attestations included, you would have a high reward. And yeah, this is EIP 7514. So this adds a max epoch churn limit. So what is a churn limit? So in every epoch, there's a certain amount of limit that a validator, number of validators that can be active on the beacon chain. So this is dynamically computed by the number of active validators in the state. So as a validator registry grows bigger, from 16,000 to 800,000, the amount of validators can be activated each epoch also grows proportionally. However, having this number too high puts stress on consensus layer clients. So to prevent that, we have proposed this EIP to cap this value to 8. So by having 8, there's a linear increase in the number of active validators on chain. Yeah, so for the ecosystem, what this means is that you would have to wait longer if you have put your deposit in for your validator to be activated. And finally, moving on to star of the show, which is the big EIP, EIP 4844. So EIP 4844 introduces a concept of shard blob transactions on Ethereum mainnet. So this is a completely new transaction type. It is not a standard transaction, so it will not be executed in the EVM. Instead, anyone who wants to propose a blob transaction would just have to sign arbitrary data and submit it to the execution client. So there would be a separate mempool for blob transactions due to the fact that they're much larger than regular transactions. So on Ethereum mainnet, a single blob would be 128 kilobytes, which is much, much higher than what is a normal Ethereum transfer transaction. So the main benefit of having shard blob transactions is that this provides cheap space for rollups to post the data in. So why have we decided to use blob transactions? So very simply, we need blob transactions in order to have it ready for full dank sharding. So rollups, before they ossify, they will need to upgrade once to, instead of using call data, you use blob data. So it is better to set the stage earlier rather than later on in a few years down the line when it would be much more difficult for a rollup to change the internal mechanics to use blob data. So another advantage of having it now is that all execution layer logic required for full data sharding will already be in Ethereum mainnet in 4844. Also, another big reason is that it allows a separate fee market for blobs. So currently, rollups, when they post data on chain, they post in Ethereum call data. This actually competes with normal transactions, which are trying to call contracts. If you want to do a swap transaction and stuff, you're actually competing with all these big rollups who are actually trying to post the data on chain. So by having a separate fee market, you can basically have a market solely focused on posting blob data on chain. So this is a summary of block space versus blob space. So in both cases, blocks are also seen by all nodes, blobs are also seen by all nodes. Theoretical limit, the highest, the limit of an Ethereum block is actually 1 megabyte, while the highest limit of the number of blobs in a block, which would be 6 right now, would be about 750 kilobytes. The big difference with 4844 is that blobs, instead of being stored in the execution client, will now be stored in the consensus client. Call data can be accessed via the EVM, while blob data cannot be. One big difference is that block data is stored forever, while blob data has a window of 18 days. So for that reason, call data is expensive, while blob data is much cheaper. So yeah, you guys can take a look at this diagram. So this is from Proto Lambda, so he works at Optimism now. But this can tell you how exactly the rollup-centric roadmap will actually work after 4844. So you would have all these separate rollups. They'll be posting blobs, and these blobs would actually be in individual blocks rather than as part of a normal transactions. So how do we attach blob into blocks? So we use what we call KZG commitments, which is a polynomial commitment scheme. So why do we use polynomial commitments rather than something that is very standard like SHA-256? The reason is that an arbitrary blob can be thought as a vector of 496 field elements. So what this means is that any arbitrary blob can be represented as a polynomial. So having it represented as a polynomial actually enables recovery using certain encoding schemes like Reed-Solomon. So this is a necessity for full dank sharding. For data availability sampling, you will not have all the field elements available, and you would need to be able to recover it. For SHA-256, since it's a non-arithmetic commitment, you cannot use it to recover these missing data chunks. So one interesting thing in the consensus layer is that blobs are decoupled from blocks. So when a proposer creates a block, it'll broadcast it to the network. And this block will not actually contain blobs. It'll instead contain the KZG commitment of these blobs. So blobs and their resultant KZG proofs are kept in a separate construction or structure, you could call it, as a blob sidecar. So the blob sidecar contains three things: the blob data, the KZG commitment, and the KZG proof. So initially, the sidecar just consisted of the KZG commitment and the blob, but because verification of KZG commitments on a normal node take 40 milliseconds, we needed to add a KZG proof, which brings it down to 3.5 milliseconds. So also one restriction of having these decoupled blocks and blobs is that blocks can only be processed when the respective blobs have also been processed by the node. So the block will have to wait for the node to see all the blobs before it can continue processing it. So one important question you guys might have is, why have we decided to decouple blobs from blocks? So we probably can't see it from this PR, but this is the title of the PR is called "Free the Blobs." So the reason we want to free the blobs is because blobs are very large, and a normal beacon block with 6 blobs would actually take about 1 megabyte in size. So this would actually saturate bandwidth in the network and have negative effects on latency and bandwidth consumption for all nodes. So when you actually have blobs separated out into different subnets, what happens is that you have separate meshes that these blobs can be gossiped in. So what happens is that you could have high bandwidth nodes in a certain mesh propagating these blobs, and basically the blobs would go along the path of least resistance. Whereas if these blobs were coupled to blocks, basically almost every node would have to gossip them. And certain nodes on the network are bandwidth constrained. So if you have a 1 megabyte blob being translated, and you have someone with a 10 megabit up and down line, it'll take literally 1 second to just download the block. So to prevent this sort of congestion on the network, we've decided to decouple them. So having a smaller message size in the case of decoupled blobs actually allows for bandwidth reduction techniques. So this is implemented in the gossip layer. So with bandwidth reduction techniques, they're much more effective if the message size is small rather than larger. So yeah, like I mentioned earlier, bandwidth can be used much more efficiently. You have independent meshes on all these blobs can be transferred on. So yeah, this is a nice chart from Anton from TXRX. So this is a simulation that was done on decoupled and coupled blobs. So on the left, you can actually see the latency is much slower for decoupled versus coupled. There is a larger spike, but that is because the higher traffic nodes which have a large amount of bandwidth, this is through which all the blobs are being propagated on. So yeah, this is a chart, so you can see on how it works on varying bandwidth capacities of different peers. So now we move on to what these shard blob transactions mean for the ecosystem. So L2s right now are bottlenecked on posting data on chain. For almost all L2s, the main costs that they pass on to users is actually the cost of data that they post on the Ethereum mainnet. Call data is expensive, it is kept forever, and due to DOS concerns, that is why its price is so expensive. With shard blob transactions, L2s have an alternative route to post data, which is through these blobs. So these blobs are much cheaper. Estimates have put it at about 10 times cheaper than current call data. So for the securities of L2s, especially optimistic rollups, you basically need the data to be available for at least 7 days. Well, currently for 4844, it'll be for 18 days. So this actually allows, in the event there's a invalid state assertion, that you can actually challenge it effectively. So 4844 provides cheap data storage that all L2s can utilize. There might also be non-L2 use cases for 4844. Maybe some NFT project needs a cheap and less permanent place to keep their JPEG metadata or something. So yeah, this is a small chart from my colleague Terrence. Basically, this is how batch posting will work post 4844. So you would have the L2 batch poster. They post the data batch to the execution client. So the execution client will package it into a blob transaction. Then when it's time to propose, the consensus layer client will take this blob transaction and build a block with it. Using that, you broadcast to the network, and you broadcast it separately to the network. So the blocks will be broadcasted as one set of peers, while the blobs will be broadcasted to another set of peers. And yeah, I think that is all.
Right. Thank you very much, Nishan, for that explanation about blobs. I like the phrase, free the blobs. The only joke for the entire day. All right, let's open up for questions. Anybody got questions about the consensus layer? CC, you got a question? I will pass you the mic. He's just here, second row. You can raise your hand. Yeah, there we go.
Yeah, quick question. Is the data sampling challenge and data recovery implemented in 4844?
Oh, so no, it isn't. So it is a big to-do. So basically, 4844 is actually setting the stage for data recovery and data availability sampling, but it will not be implemented in 4844. But what 4844 does is that it builds like all the requirements for rollups to use a cheaper form of storage. So in the future, when we do have full dank sharding, rollups won't have to change anything. So the execution layer client logic will be unchanged. The only thing that might be changed will be on the consensus layer.
Okay, thank you.
Okay, thank you for the question. Thank you for the answer. Anyone else? Over this side. Oh, I'm so sorry. I didn't see behind me. Can pass. Not him. Him. He was pointing to him. Yeah, the guy in the black shirt at the end. Please introduce your name as well as your question. Thank you.
Hey, thanks for the talk, Lib. I got a question regarding 4844. Like, why do you think that it should be a hard fork? Why is it like an EIP? Why isn't it like a sidecar that is an optional add-on? Because it seems like, the history of Ethereum is that you let the protocol layer be as flexible as possible, but this seems like a very application-specific thing for like blob transactions for L2s. Why don't you keep the layer light and have this sidecar, optional sidecar, just like PBS, and then enshrine it in the event that it does become popular?
I mean, if you do the latter, you have issues like Lido popping up. So, but one reason we want to do it now is that we do understand that Ethereum is being used for rollups a lot more than it was 2 years ago. there's a definite need to have cheap rollup transactions, even though it's a bear market. So at least having this set right now would actually allow rollups to upgrade to using this blob space rather than the cheap call data. I mean cheap, but call data that they use right now. Also, a lot of things that rollups require do need a hard fork, so you can't actually have it optionally. So like they need some EVM opcodes to be implemented so that they can actually determine what is the gas price of blobs and stuff like that. So I don't think it can be optional.
Gotcha. Thanks.
Thank you for the question. Anyone else? Raise your hand. Oh, you got one? Oh, got two over here. Yeah. Go ahead, and then we'll pass it to the bank.
Yeah, regarding 4844 as well, how much of a performance degradation does 4844 has on the consensus clients?
So there was significant bandwidth issues with the old design where blobs and blocks were coupled. So after decoupling it, there might be a slight increase in bandwidth, but due to blobs, being broadcasted on separate meshes, it is a lot less than what it was before. So in terms of block processing times, the only gotcha is that because blobs and blocks are decoupled, all clients will have to wait to see all the blobs before they can process it. So there are certain edge cases where a malicious proposer could just broadcast this block with these KZG commitments, and it will not broadcast the resultant blobs for those. So you could just have the client waiting to see the blobs. But yeah, that is one possible downside, I could say.
Thank you. Sorry, one more question. Regarding 4788, is the contract going to be introduced as a pre-compiled contract, or is someone going to deploy that contract and make it trusted? Yeah.
So from what I understand, it will be a pre-compiled contract. It's still being audited, but yeah, that's what I understand.
Thank you for the question. I can pass to the gentleman at the back. Do Ethereum developers ever laugh when they say, "Can I see your blobs?" It sounds very funny. Okay, please go ahead, sir.
All
Thank
right.
you.
I think you touched a little bit of in your previous answers. So my question is, you mentioned that the block and the blob will be detached and propagated separately, right?
Yeah.
And then and you also mentioned that the block cannot be finalized if you don't receive the blob, right? So does it mean as a consequence we won't be having two epoch finalization?
Oh, no. So that is a separate thing. Basically, if, let's say, a malicious proposer broadcasts the block without the blobs, it will not be inserted into like the client's fork choice. So the fork choice is like, you can think of it like the internal like linear chain or internal chain that the node uses to determine what is the head. So the blob doesn't come in, it's not processed at all. Just that there's a weird case where it waits for the blob in order to be processed. So there's a timeout, I think, that's implemented in all clients. If after X amount of seconds, you don't see the blobs, you just drop the block. Yeah.
Thank you. Anyone else want to ask a question about blobs? Oh, yes, in the front. Yes, come. We have one in the front here. If you don't see the blobs, drop the block. Yeah, I'm going to remember that. Write it down on my Instagram.
It's not about blobs. So you've been as like corn dev for a long time, and you probably realize there aren't many corn devs in Southeast Asia. For those who want to be a corn dev in the Ethereum space, do you have any suggestions?
Yeah, so Ethereum has this really cool fellowship program. So a lot of, I think, new people who join core development, they have actually come to the program. So we've actually hired a few people who have participated in the fellowship program, and using that, they're now part of Prism. So, if there's anyone in this room who's actually interested, definitely do check it out. We have a lot of cool projects that, maybe core developers can't focus on, but they have been picked up by, all the fellowship participants, and they've done a great job with it. So, if you're a core dev and this is something that interests you, you can definitely try that.
Great, thanks.
Anyone here interested to be a core dev for Ethereum? Oh, we are. Oh, some. Yeah, join the fellowship program. Do you have a... He's a fellow, or he's already a fellow. Yeah, so okay. That's fine. Any last questions before we wrap things up? Anyone else want to ask something? Yes, okay, yep, come. When he asks questions, it sounds like interview. But it's okay. It's okay. Questions are good.
I'm sorry that it sounds like.
Don't apologize. We still got 5 minutes. Please go ahead. Yeah.
Okay. I wanted to ask what's after Denkun. So on the execution side, there has been talk on EOF and vocal tries. I'm specifically more interested in the vocal try side. If let's say vocal tries were to be implemented, what are the changes that the consensus side should take note of? Yeah.
So for vocal tries, I don't think the consensus layer has to do many changes. Probably due to how the vocal tree be bootstrapped, that'd be one concern. But I don't think off the top of my head it's something we have to worry about.
I think there has been talk on including proofs in blocks itself. So I'm not sure if I still remember correctly. Do you have that insights on that? Yeah.
There might have been conversations, but I'm not too sure about that.
Okay, cool.
Yeah.
Okay, thank you very much. Anyone else? Going once, going twice, 3 times. Let's give our speaker, Mr. Nishan Das, a round of applause. Thank you, sir, for teaching us about blocks and blobs and consensus layers and chains and lots of interesting stuff. I can see the audience enjoyed it for sure. They're asking a lot of fun questions. All right, ladies and gentlemen, we've come to the end of day 1. Give yourselves a big round of applause. Welcome. Thank you so much for joining us. This is day 1 of the first Ethereum conference in Malaysia, so it's a historic moment. Tomorrow, do you know what time we start? Today was 8:30 registration. Tomorrow morning, do you know what time we have to be here? 10 a.m. 10 a.m. You can come at 7:30 and then look at the sunrise lah, if you want to come. You can always come earlier if you want to do networking, because I honestly think the networking outside is one of the most valuable parts of a conference. But our next session will be starting here tomorrow morning at 10 a.m. and also the other venues as well, JC2 and JC3. Tomorrow's topics are going to be more about DeFi. About DeFi trading, decentralized apps, building crypto in Malaysia, and also the end of the day tomorrow will be our closing ceremony and the hackathon results. Yeah, we're going to be doing the hackathon results, and the hackathon finalists will be presenting their projects as well. So that's going to be really exciting tomorrow. It's not going to be until 6 p.m. I think it's about 10 a.m. to about 5 something around there. So please come tomorrow early morning, a bit earlier if you want to network. If not, just come here at 10 a.m. All right. Thank you so much, everybody. Good night. Please drive home safe. Oh, don't forget the side events. There are some side events going on. If you're going over, please enjoy yourself as well. And we'll see you tomorrow. Thank you.